All right, let's see here. I need to buy some stuff at the very beginning of stream here. Oh yeah, the solder sucker. I need to get another one of those. What was that thing called? It was it wasn't the engineer SA whatever. I'll just Google solder sucker. Solder sucker. There it is. Oh, it is engineer SSO2. Is this the one that uses the Star Trek font? Looks like it is. All right, we're gonna buy that one like immediately. Oh, you can buy just the parts for it? SSO2 cylinder. Wait a minute, what were the different options? SS1, and then just silicon tube, which you should not buy the silicon tube from whoever's listing the solder sucker, because you could just get generic 1/4 inch. All right, the second thing that I needed was a DVI to HDMI. Because the one on this computer has routinely been annoying me. Wait. No, it's DisplayPort. DisplayPort to HDMI. The one on this computer is really bad. It doesn't quite work. It looks like the only ones I can get are the same style. Eesh. I don't know if I want to trust another one of these. It's like $10. It's like a little digital converter. But they don't like to work with the HDMI cable that I've got it on. And that's what brings my second monitor its video signal. So I need to unplug it and plug it back in a bunch of times in order to get it to work. And Amazon does not let you organize things anymore. They don't do that. So I can't look at what the best reviewed one is. I'm not allowed to have that information. I guess Jeff Bezos still gets to have that information, so he gets to like get all the good stuff. Which one did Jeff Bezos buy? Maybe that'll tell me which one's good. Sorry, I'm being a little quieter because I had the puppy down here, but as soon as I made any noise at all, she fled. She just had to get the hell out of here. She's like, I'm leaving. Oh, I need Chatterino open. Shut up. There's Chatterino. Let's get that going. There we go. Good luck with longer cable DisplayPort to HDMI. See, the thing is, I've got like one of those super thin ones. What's up? How's everybody doing? How you guys doing? I see chat now. I have one of those thin HDMI cables because it's the only one that I could reach over here with. And I think maybe that might be part of the problem, because I think there's some converter in that HDMI cable that turns it into something with less pins, and that sends it out the distance to the other thing, and that can get out of sync. It's like a singular direction kind of cable too. So you know what I need to do? What I really need to do is take everything out of here and reorganize it and put it all back in, because it's had stages and it's sort of built up over time. I need to put both streaming monitors up on the top shelf up here. I have one here, one there. And that way the microscope would be a straight shot and the other monitor would be right there. And I'd have the face cam all the way on the side of this monitor, so I could put chat in the middle or chat all the way on the side, and it would still kind of look like I'm addressing you guys. So I think I need to move the programming monitor from down here, because when I program, I look like this. And you guys get streams of me looking like this. It's not good. It's not a good look. Silurusol, why, thank you for the sub. Look at that. Beautiful. It's beautiful to see. 62 months. Pretty nice. The Kubrick program. All if statements and no do whiles make oh bother. I don't know. 4K display, blah blah blah. I already ordered that one. Shit. What's this one? Anchor. Do we trust Anchor? ANKER. I don't know if I trust Anchor. It's like so generic. Oh, that's to USB-C. I already have that one, actually. That's to USB-C. I already own that one. I don't have a USB-C on the back of my 970. Then again, I could solve this problem by putting the 1080 FTW in this computer. I could do that. I could do that very easily. Maybe that's just what I need to do. I hear the dog barking. Head down, glaring towards the camera. My problem is it doesn't look like I'm looking towards the camera. That would be if I put the camera actually down low. When I look at this monitor right here, the camera is significantly above. It looks like I'm looking at my own belly button. I'm navel gazing, and that's not a good shot. So I need to move this monitor stand to this area over here on the top shelf. There is no space because the top shelf is full of like weird dregs of projects. If I get more organized, which I'm always trying to do, I could possibly move some of this stuff to a place, because it's like seldom use kind of stuff. I need to kind of move stuff over to the right, and then I can clear off this little storage spot right here. It'll make me feel better about life if I have my stuff a little bit more organized anyway. What's up? Nothing's working. Speaking of nothing working, it's always a segue into, let me open up MS Paint. Still problems with my anti-lock brakes. The light still comes on, and I think it's well, I don't know what I think it is, because I was right about my previous theory. I got my brakes back. For those that don't know, I've been having a lot of troubles with my BMW anti-lock braking system. Anti-lock braking system is a fairly complicated thing that's been sort of tacked on to the end of the braking system, so that there are some pass-throughs and check valves and feed-throughs and stuff that allow you to still operate the brakes with the pressure of your foot. However, if the anti-lock brake system kicks on, it can add pressure, it can release pressure, or it can maintain pressure on those lines. And so it uses all of that in order to keep you from spinning out of control and exploding. However, when you get air in that system, there are a lot of little nooks and crannies that bubbles can hide in. And so right now, my brake pedal goes all the way down to the floor. But that's only if you put sustained pressure on it. There's at least a little bit of feedback on there, and I'm able to hit the brakes properly. Problem being, after a little while, ABS light comes on, and I don't know what that's related to. The computer will tell me this time. What the computer told me last time was it was due to a pre-compressor pump that I replaced. But that pre-compressor pump being replaced with a big old air bubble in the middle of my ABS system. So I took it when it was raining. It rained for like a whole day here. Cold and raining. Took the car out. Did some skid stops with the ABS going psycho during the whole thing. So that worked out. I was able to get that system running. I tried doing it with a computer, but apparently that didn't activate it properly. So did all that stuff, then parked my car until Christmas Eve. right? Yeah, I got a little foot massage out of the whole ordeal. Park my car until Christmas Eve, wake up late, so I got to rush out the door. And when I hit the brake, yeah, it's a really unnatural feeling because animal groin, I had to drive 5 hours with that. The pedal went all the way to the firewall with almost no force at all, except at the very, very end, I got a little tiny bit of braking pressure. And so my theory was that there was a bubble in the part of the braking system that is connected to, like, between the master cylinder and the ABS module. That little pump from the bubble from the pump got in there. And so now my brake pedal was completely loose almost the entire travel, which means I got the bubble out. But I had to drive 2.5 hours down, 2.5 hours back with that brake pedal. I had to give long follow distances, and people were being complete psychos on the road. Anytime I hit the brakes, I had a panic in the back of my mind that I was going to die until I finally got all the way down to where the brakes were applied. They still worked. They just worked at the very end of the travel of the pedal. Not a good feeling. So when I got home, I put the car up on one corner. I just took the driver's side wheel off and bled that with the brake bleeder, which is this pile of crap that's sitting behind me. Bled that and almost immediately got a bunch of bubbles. So I think my theory was correct. But in the meantime, I actually did a little bit of research into finding a diagram of the system, because I wanted to know what kind of bleeding I was in for. So I found this diagram here. Let me copy it and put it into Paint. Hold on one sec. I got the diagram of the system right here. This is it, boys. The Bosch 5.7 anti-lock braking system. So we got a bunch of stuff going on here, and it's kind of a difficult, it's a difficult diagram because it's been condensed. This right here, this is the part that I replaced. So this is where the air came in. Now there might have already been bubbles in the system because the behavior of the gas pedal or the brake pedal right now is like it used to be. But you've got a pump motor here which does both sides. I don't know about the charge pump only doing the left and right fronts. I think because the charge pump, there's a charge pressure sensor right here too. I don't know if that's related to this pump adding pressure to the system or not. But what's supposed to go on is if there's brake pressure here, that's going to feed down. This little capacitor symbol means that this is closed. That valve is closed, this valve is open, and this switches to a check valve. We've got a pump down here which is adding pressure, and I would assume it's from this side. Because if that pump goes, it's going to take its charge from here and pass it where? Back up? It's a very weird system. I'm trying to get a handle on this so I know what to open and close. This is an accumulator, so that's going to take in pressure. I guess that's also some kind of an accumulator. I would have assumed that the bubbles were basically here, and that's why it affected my whole braking system. They were in the pump, but then I somehow was able to put them back this way, because there's a check valve right there that's keeping that from opening. The anti-lock brake unit has 3 modes, right? One is maintain pressure. Well, 4 modes. Inactive, maintain pressure, add pressure, reduce pressure. 4 modes. And it uses all these pumps and valves in order to achieve that. So if I hit 30 miles an hour, this thing charges up. I would assume some kind of a preload valve opens up to allow it to add pressure to this part of the system, so that when this pump activates, extra pressure can feed down and into the brake. But then it would change over to an outlet and allow it back up through here, through there, and all the way back up to the cylinder, I guess. I don't really know. This is like kind of a complicated system. So there are explanations of how all this stuff goes together, but they're on the later models of my car and the follow-up to my car, in the computer stuff, there's an auto sequence that you can go through that activates all these modes, and it just goes through them, and it ends up knocking any bubbles free. I don't have that option. I don't have that mode in mind. I can just actually Oh, display port to HDMI should just be pin out. There's no conversion. It messes up this monitor. Maybe it's not the converter. I don't think I bought one just now. But yeah, you activate these valves in order to get the different behaviors out of the different brake operations. But apparently in order to bleed it, what you do is you activate the charge pump, then you activate the regular pump, then you activate the inlet, then you activate the outlet. But I don't think that's the smartest thing to do, because if I'm running the charge pump, I'm adding pressure to this part. So we've pressured this up, and now I've got this pump going too. So we've added pressure here. So once we have pressure in this part, if we activate the inlet, that cuts this off right here. So now we're just charging this area with pressure, and I guess it's still allowed to go to the rest of the calipers. But this one would get less flow on it because you wouldn't be able to get that. Nothing's coming in here. So if you activate the inlet valve, that would mean that pressure gets through here, and we've got higher pressure there. When it lets off, I guess it'll let through that check valve. I guess you would have to activate the outlet, which pulses, and that pulse would actually fill the accumulator. There's no flow to any of this. What you're doing is your brake fluid's leaving through here, right? So if you have brake fluid leaving this path and you cut off this path, it can't get through the check valve to get anywhere. So you would have to leave the inlet open, and so then that would flow this way. And then I guess you could open up the outlet. If you opened up another brakes outlet and then this and left the... No, wait a minute. How does that even work? So it's flowing this way, and you open up the outlet, what happens? Nothing. Yeah. Nothing's going through this part of the circuit right here. So if you didn't have the inlet active and you activated the outlet, nothing would happen. But if you activate both of these, then the pump is cycling through here, and I guess still evacuating on that same spot. Huh. I do not know. The problem is the pedal's still very squishy, so... I mean, I did activate the preload valve at one point, but that just loads it from, I guess, the charge pump. It's like that. There's like an ASC bypass valve too. I don't get it, man. This is a weird system. I feel like I need to program a sequence. I need to figure out how to make sequences in that program that tests the different components. No, I actually haven't found the factory bleeding procedure. I think that is what I described as the factory bleeding procedures. You open the inlet. Well, you activate the pumps. So you'd activate pump, and then you'd activate the other pump, and then you would open both valves. So you'd activate the inlet and you would activate the outlet. I was activating the inlet, waiting, and then activating the outlet, just so that there was some flow through it. But I mean, when you cut off this part, it's not like you're going to get flow through here because there's a check valve. No, I never got an estimate. No, I'm not getting an estimate for that. I'm going to fix this myself. The brakes work now. They work. There's just it feels like there's probably air somewhere in this pipe dreams kind of ridiculous fucking thing. Like, if I just activated the outlet, then that would create flow. That wouldn't create flow, actually. This part of the circuit, I don't know if I can get to. I think the only way to do it... Yeah, okay. So it would be changeover, preload, charge pump. No, but that goes this way. So if I just did changeover pump, and I was bleeding it out, then no new brake fluid would get in. That wouldn't do it. That wouldn't do it. That wouldn't get rid of... I mean, if I didn't even open... If I left this closed, then what that would be doing is creating a circuit like that. Maybe that's what I need to do. So activate the ABS pump, open up the outlet valve of each corner, and that might push some air into a part where I can actually bleed it better. There might be air here, which would cause the brakes to feel spongy. No, not at all. No, that's not true. They wouldn't feel spongy at all. And then again, like the pipe structure that we're looking at right now, that's not how the real thing is designed. It's actually different than that. It's going to be different than that. So, oh yeah, Celia Russell's JPEG. Take it easy. We're in the days between New Year's and Christmas, which means offices are barren. I loved going into work during this time because there was nobody there. And what little I had assigned to me, I could just do and then slack off for the rest of the time. Paid to sit at a desk, living the dream. I don't understand the system at all. Like, how do we return to the reservoir? I guess that's by releasing the brake pedal. When you press the brake pedal, it locks in and pushes fluid down and pressurizes that, right? So with this getting pressurized, once you release, I guess is when you would have the connection between the two. These check valves are throwing me off. I didn't see anything that resembled a check valve in the system when I took apart just that pump, just the charge pump. So charge pump puts pressure into all this stuff. There's a little bit of extra fluid for some reason. Preload valve is closed, changeover valve's open. Pressure down here. That goes through the inlet valve and to the brakes, right? That's normal operation. When ABS wants to bleed out pressure, it can close the inlet valve, open the outlet valve, and then that pressure will go into the accumulator. And the system will be lowered in pressure. If it wants to maintain the pressure, it can close the inlet valve, and that will maintain the pressure on the brake for what it's worth. If it wants to add pressure, it can open the preload valve, pump, activate the pump, close the changeover valve. Pressure is now being added to this branch of the system. That's both fronts. So it can close the inlet valves, and if it needs to, open the outlets. This is a complicated dance. I don't know. I don't know how I more effectively bleed out the air in the system because I followed all the steps. They want you to activate both pumps, open the inlet, and then open the outlet on each caliper to bleed it out, which I don't really think exercises the system in the way that you think it should. Because you don't really open the inlet, you actually close the inlet. So the more betterlier way, activate the pump, activate the preload valve, activate the outlet valve, possibly even close the changeover. Because you want flow to be down through all the different facets of the system. You can't really get to this one very easily. Unless... No, there's a check valve right there. You're only going to take it up through the pump. It would almost be like you would want to go through the pump, down, through a different caliper. That doesn't even work. You'd want to just like cycle that a couple times, and then you could bleed it out through there. That's ridiculous. How does that even work? I'll close this one too. Like if you closed both of those, I guess you could pump cycle it and like try to circulate a little bit. So you would keep that. You would flip this over. You'd activate this one, activate the pump, open another caliper's inlet, or sorry, outlet, open another caliper's outlet, and that would create a static flow through that circuit back to the pump. And then you would bleed it off this way. And the check valve would keep it from... I guess that's the only thing you could do, yeah. All right. Well, I got something to try. I don't know if that added pressure is going to end up... Because you would want to cycle it, and then you would open it up again. You'd open this up again, or you'd open up the preload again, and then you would be able to bleed it out. But that... They only run for a certain amount of time. God, that's so weird. You would have to bleed it through another wheel's circuit. I guess you don't... It doesn't have to be through another circuit, but you want to be able to catch the bubbles wherever they may lie. Maybe you would just do it through the one. You would just open up the outlet, and then the pump circuit would be like that. And then eventually you would catch it by opening this up. And then that check valve would allow more fluid to go down into the system while you pump it around. So you'd want... and it's not called changeover in the... Let's see, INPA... INPA E36 ABS activation. I'm just looking for the activation menu. See, this is what's in the good ones. This is what's in the ones that I don't get. I don't have that. Rework bleeding caliper, front left, right left, blah 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 blah. I don't get that. I mean, it exists. I wonder if I could copy it from anywhere. We're gonna do the ghost hunting circuit in just a little bit here. I'm just getting distracted as I usually do. There was a thread that had a picture of the menu on it. Like the one that I'm looking for. Active screen for the DS. I wonder if there's like a page 2 to the DSC, the active thing. Crossed line test? I don't have any of this stuff. Watch there be a page 2 in the menu that I'm missing. And that's what this is where this whole thing came from. It's just I just didn't find the page 2. Blah 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 blah. Low viscosity .4. Uh-oh. I use slightly different brake fluid than that. Air enters the DSC hydraulic unit. Bubbles may adhere to the edges of internal valves of the unit. These cannot be removed via conventional flushing. In that case, it's necessary to bleed brakes using a BMW scan tool or equivalent. Yeah. He's .5.1. I hope that's okay. Where is this menu? Hold on. I was able to find it so easily before. That's not what I have. It's not that activated menu. Every stream. Every single stream. 5.1 is probably overkill. It's what I Googled it really quickly before starting all this fiasco, and it's just what I found immediately. So, and then as usual, I end up reading stuff and I find out it's totally stupid. But I always end up reading. You should avoid 5.0. Okay, good. I didn't fall into that one. Activation menu. Yeah, isn't 5.1's compatible with 3 and 4? This is the menu I have. If only we had a little bit more resolution in this. House music wants you to know that it's house music. Oh my god. I turn this music down just a little bit. At least for you guys. Z3, blah, blah, blah. I just need, like, I want a picture of the menu, damn it. I don't think this is it. Let's just, INPA E, oh, I did E36, E39 activation menu, ABS, sorry. Did I say something stupid? No. No, I can assure you. There it is. So yeah, this is all I get. Okay, the image isn't zooming in. Post image, I hate you. Open image, a new tab. There it is. Okay, now I can actually zoom in like an old man. So here's how I activate the different parts of the ABS system. Intake valve, front left. Intake front right, blah, 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 blah. Exhaust, front left, front light. Pump, preload pump 1. Okay, that makes sense. ASC cutoff valve, huh? What's that? ASC cutoff valve 2. Wait a minute, what's that? ASC preload valve 1. Okay, I kind of get that. ASC preload valve 2. Oh, okay, I get that. Preload pump 2. Wait a minute, what? I only have one preload pump. Give me a break. Schmide, thank you for the 52 months. I appreciate that. Yes, break me off a piece of that Kit Kat bar, but you couldn't read the irony in my spelling it wrong because I said it out loud. I'm just trying to get a handle of what the hell I'm up against with my brakes because there's still clearly a bubble in it, I think. Dot 5 is silicon based, the others 3, 4, and 5.1 are glycol. Uh-oh. Well, maybe I put the wrong one in there. E39 brake fluid. I did a flush though, so 96 2003. Dot 4. Dot 4. Dot 4. Dot 4. I'm seeing a trend. So yeah, I guess I'm good. The reservoir cap says what it needs 90. Oh, I should check that. It does. There's a little thing, a little text behind the bottle. Well, I'll check some other time. Whatever I have, I guess, is compatible. It's just overkill. All right, good. So yeah, this is the menu that I'm faced with. I use the F keys in order to trigger stuff, and it triggers it very slowly. When I do the exhaust valves, it'll click them. Click, 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 click. So, I would assume the preload valve is the preload valve. So 1 and 2 would probably be insinuating front and rear. So I have preload pump, preload pump. Well, the 2 pumps I don't understand. I only have 1 preload pump. It's just that, the charge pump. There's the pump. That's the actual ABS pump. You can hear that one turn on. The preload pump I don't hear turn on, but there's no warning associated with it, so I assume it works. ASC cutoff 1 and ASC cutoff 2. That has to be the changeover, because the other one is preload. Actually, wait. ASC cutoff and preload. Yeah, cutoff and preload. So changeover valve would be ASC cutoff. And I assume they probably work in tandem, even though there's no schematic representation of that right here. So the outlets get pulsed. The inlets just click over. Pulsing the outlet opens up this part of the circuit, but you would have to have the pump going in order to keep it circulating. And then that would push bubbles out along with whatever's coming in here. But the ASC cutoff valve, yeah, that would actually cut off any additional brake fluid, which is not what you'd want. You could potentially chase bubbles out of the other side by cycling it through there and then draining it out the 1 caliper, though. Okay. All right, I think I get it. I think what I need to do is actually activate the charge pump the preload, and the pump, unless I want bubbles to go back and up and around, which I think is bad. Because the preload would put pressure right here. I would have to activate the outlet. So I could probably get away with just activating the outlet. But I don't think there's any need to activate the inlet, except for this little piece of the circuit right here. But then again, if there's overcharge here, it'll go up this way. Well, that's not really strictly true. So keep the inlet open, activate just the outlet, maybe the preload valve, and you can do this circuit. You can do this circuit. Actually, wait, if just that one, then you'd be doing this circuit. Like, okay, all right, I think I get it. I think I get it now. I don't really need the ASC cutoff, but if I did, I would also do the preload. This is wild. Scared to see how my car does all this. With any luck, you've got software that'll help you with it. All right, that was car talk. I'm just for those of you that are you know just joining us. Hold on, I'll come over here and address you people. For those of you that are just clicking on this because you saw ghosts, the reason that stream starts soon is still up is because I haven't started stream, and there's somebody that asks every single stream. I guess there's just a certain amount of people that I'll never reach, that will never sort of internalize the fact that if there is a timer up on screen and the stream says, I'll be starting in 5 minutes, 4:59, 4:58, they have technically started their stream. Their stream is going. They're doing the exact same thing I am right now. It's just that I have a camera rolling during it and I'm talking to you guys. Because I don't want to just sit here like not saying anything. I don't really have that much to set up a lot of the time. And so all I really need to do is just sit here and wait until I start things. It's more fun if you guys are here while I'm turning on lights and stuff like that. So I turn on lights and stuff like that, and then I hang out for a little while. And then I spend a significant amount of my time explaining to you guys why Start Soon is still up. No, explaining to one person every single time why Start Soon is still up. It's one of those weird conventions of streaming where somebody did it once and everybody just kind of like follows suit. They just kind of follow suit with this starting soon thing. And I'm just about the same. I saw other people doing it. That's a pretty good idea. It allows me some time to let people filter in, let the numbers grow before I jump into the project, and that way I'm not explaining the project my entire time, although that ends up happening anyway. So the point of what we just went through is I just spent 5.5 hours driving down to Maryland and back with an extremely loose brake pedal. Basically went almost 80% of the way to the firewall before I actually got any force behind my braking, which caused for a lot of kind of panicky stops. The brake pedal was completely and utterly firm before I ended up driving home. Why did this happen? I put the car in the garage where it was slightly warmer than slightly warmer than the 7 degrees that it fell down to for the day or so that it was parked. What happened was the infinite complexity, the pretzel that is the piping of the anti-lock braking system pushed a bubble out of it. I replaced an entire part. Hold on. Part box isn't plugged in. I'll plug it back in a minute. I replaced this entire part. So there were bubbles in this part of the system. So what happened when the day before, when it was raining, the day before I parked the car when it was raining, I took the car on a little joyride in order to activate this entire system a couple times. And I suppose that whatever bubbles were in this thing were pushed out into this area. Well, this area is the entire front brake system. So that right there ended up having enough bubblage in there so that when I hit the brakes, the pedal would fall all the way to the floor. It doesn't take a lot. It doesn't take a lot of bubble in order to cause that to happen because there's so little fluid motion in braking. Now, what I did when I got home is I put the car up on the jack, took the wheel off, bled just one of them, and I got a big bubble out of it. So my pedal firmed up again. But while it is firm, it still gradually falls all the way to the firewall, which is the way the system was before. I found a diagram of the system, though, and that told me all of the different nooks and crannies that exist within there. I have a little bit of a better idea of how I can go about bleeding the brakes. I got a ton of fancy brake fluid that I would like to get rolling in that thing. I don't know when I'm going to get around to this again, because right now the brakes sort of work. There's another problem with the DSC. There's another problem with the anti-lock brake system. So I have to read the computer and see what it's telling me is wrong. I hate it. It's always a different, unique warning light. But we were just talking about the braking system. I wanted to get a better handle on how it works, because ABS does 4 things, right? It adds pressure to the brakes. It releases pressure from the brakes. It maintains the pressure to the brakes. And it allows the master cylinder to directly control the brakes. So, yeah, well, I have the power bleeder, which is in that box right there. I haven't been able to clean up. The power bleeder helps a lot, as opposed to the suction bleeder. I think the power bleeder is pretty good. I need to take my clutch pedal off again and bleed that again, because BMW apparently didn't give you an easy way to get bubbles out of that thing. There's a spot on the brake master or the brake slave cylinder where the bleed screw is. It can retain like a pretty big bubble right there. So you have to take the whole thing off and like tilt it around in order to bleed it. I think my clutch is still a little wonky, which could be causing the ABS light to come on. I have to see what the computer says. That's going to direct me to my next thing. Yeah. If I was just doing a brake fluid flush and not replacing the entire master cylinder and the entire charge pump, then I'd be sitting pretty. Everything would be just back where it was. I'd be totally fine. Because the regular brake system is very easy to bleed. It's just when you add the pretzel of plumbing that is ABS to the rest of the system, there are nooks and crannies and valve faces that can gather bubbles. So I don't understand. You were talking this in the previous stream about, like, I complain about ABS and you're like, that's why I buy old cars. How old are you buying, dude? ABS is a legitimate system. Like, it's actually very safe. It's a very good thing to have in a car, especially in the fucking Northeast. I was saying basically the same exact thing to this friend of mine who's all about Tesla. And I'm like, you still have, and like I had to explain to him, like, you still have an anti-lock brake system in your car. You can't lord over me the fact that you have a Tesla and I'm struggling with anti-lock braking problems. You have the same thing in your car. There are certain systems that are part of cars that are not going to change when you change the locomotive method to it. And in that same vein, the safety systems that are implemented within a car, the reason that in 2002 or 4, ABS became required in all cars is because it really fucking works. You retain control while you're trying to brake the car, while you're trying to stop the car. Yeah, I had Mark II VWs for a little while. They're okay. They're a little played out. It's like Mark II VWs are like Rick and Morty. Their fans have ruined them. 2014 Nissan Altima because it was cheap. Yeah, I've done a long road rally in a Mark II, and it was in running pig rich the whole time because we blew up the computer by accident. So, still though, I just, you know, I just got to get the remaining bubbles out. I'll get there, but I have to see what the computer's telling me is wrong. I definitely have to see. The computer will tell me what's wrong and why it's not allowing me to have ABS, because everything is there. Everything's there. I've replaced all 4-wheel speed sensors. I haven't replaced the brake pedal sensor, and if that's bad, because apparently, as opposed to the newer ones, which I have right here, the older ones are still a no-contact Hall effect sensor, right? And it adjusts. So your brake pedal hits up against this thing and adjusts it. And so I went under the car and I went, boop, and then let the brake pedal run into this and push it back. That's all well and good. 2 wires coming out of this mofo, which means continuity to ground when the brake pedal's there, no continuity to ground when it's gone. However, mine, on my older car, has 2 circuits in this thing. One of them is so that the computer can check to see if this thing works, and the other one is to turn on and off the brake lights. So when I was testing the brake pedal, brake lights turned on and off. That was fine. But there's still an error. At a certain amount of distance, the lights come on again. So it could be the other half of the brake pedal sensor is bad. I don't know. I tried to bench test it, but that didn't work out. So I do not know. I do not know what the problem is. Maybe that's for another day. We might be able to do that here. But again, the computer will tell me. There's the wheel speed sensors. There might be crud behind a wheel speed sensor, and so it's getting a slight value that it doesn't like. I really hope it's not the steering angle sensor, the angle of the wheel sensor. I have had the car's alarm turn on in the cold randomly, and that might be a tilt sensor thing. So that tilt sensor might be bad, which would be a very intermittent problem. So if the computer tells me the tilt sensor's bad, I replace the tilt sensor. I think they're not terribly expensive. I can throw a new one in there. And then that would make another problem make sense. I don't think it's the rotation sensor. There's all these sensors it's kind of cool because it knows how your car's tilting, and it knows how the speed at which it's turning. It knows the angle you're holding the wheel at, and then it knows the speeds of all four wheels, and it also knows the pressure you've put into the brake. Crazy. It's crazy. And it uses all of those systems in order to determine how it should be stopping your wheels or allowing them to move. And it did this in 1999. Pretty cool. All right, anyway, let me get the music out of here. Sorry, I got distracted. I love talking about this kind of stuff. If you guys couldn't tell, you know, if that wasn't like my whole stick. Okay, I misclicked. I meant to fade out. Start soon goes away. There, are you happy? No more starts soon. You guys happy? They should have had 4 wheel steering to make it more complex. God, it's all control systems. You know that, right? It takes the amalgamation of the inputs and it says, I should be rotating this much and the wheels should be going these speeds. And it says, what is the error percentage between what I'm seeing from the sensors and what I'm calculating I should be getting? Oh no, that's off. How do I deal with this? And the inside brake a little bit more, outside brake a little bit less, et cetera, et cetera. That's what it does. It just does that, and it does it in, real time very, very quickly. There is no dog here today. I started talking and she just left. As soon as I actually had the audacity to move something, and she just got up and left. So if you want to see the dog, you got to go to the Discord. You got to go to the Discord. She's in the Discord. I posted a bunch of pictures of her. She's been a very tired baby because she's had an entire holiday, a couple days where she's been at my brother's playing with the Finnish Spitz. She also met another family member's cat, which was a monumentous occasion for the puppy. She has not met a cat before, so now she's met a cat. Apparently they circled each other for a long time. But yeah, puppy pictures are in the Discord. Hi, I'm back. I'm back from the holiday. Stream schedule was only slightly interrupted because I had a little bit of craziness with helping people load things into cars right before the holiday. Then I have the audacity to try to drive my car across a couple states. And just as I go to do that, my third brake light decides to shit the bed. Wait a minute, why didn't this light turn on? Hold on a sec. Why are my lights going weird? Everything's breaking for some reason in my life. One sec. I gotta go back to this screen, and then I have to do stand light. Yeah, see, these get a little weird. I think there was a power surge at some point that reset a bunch of stuff, and everything's breaking except my car. My car is what I'm desperately trying to keep afloat. Everything else is just kind of breaking. It's the only one that actually gets an input from me. Yeah, I don't know, my lights got a little discombobulated. When there's a power outage or surge, everything turns off and on at the same time, and then things start to get a little weird because their IPs are all coming back up at once, and my router doesn't like that. So I just need to reboot this, and then hopefully that'll allow me to toggle it again. Because this light comes on automatically when I switch scenes, and that gives me that third point of light, but it doesn't screw you guys up when I flip over to the face cam. Like that. That should turn off. But it's already off. There's no clicking noise. Damn it. Come on, man. I don't need this today. Why is this all weird? Oh, we have to do a 180. There you go. Sorry, my USB cables going to the cameras are a little bit tight. So yeah, let me just get this light working and then I'll explain what's going on. My recent thing was just that my third brake light went out. It turns out this entire PCB had it was just your most basic one-layer PCB, right? Well, not your most basic, actually. It was slightly more complicated one-layer PCB. It had a solder mask and a silkscreen layer that was made in the 90s. And apparently because of the position that this thing sits in spite of the fact that it is all LEDs, the circuit board the side of the circuit board was subject to moisture. And as such, it completely obliterated the traces on the board. So all of that solder mask and trace material was peeling up, not to mention the fact that when I powered my car back up, apparently running from 10 volts for a particularly long amount of time, suddenly going back up to 12 to 14 volts, had an effect. And the effect was the diode cracked in half and all of the resistors had rust on their traces. So I replaced everything and I actually put surface mount resistors on this thing, soldered the whole thing, spent all this time, this is Christmas Eve that I was doing this, sanded down the back of the circuit board to the point where I could access all the copper and put solder down and like solder repair all of those traces, right? All that work, power it up, 2 of the LEDs are dead permanently. So fuck that, fuck this circuit. This circuit, by the way, this circuit is 6 LEDs, right? 6 LEDs. The first leg has 2 resistors leading to it. Then 3 resistors leading out of it, 6 more LEDs. So it's 6, 6, 6, 6, right? It's the devil. You got 4 banks of 6 LEDs. They all sit between 12 volts and ground with multiple resistors, but only 2 at the top, 3 on every other bank. What the hell? Why did they make it like that? I ordered a whole new unit for like $40, right? So that'll get here sometime next month. I don't know, sometime between this month and next month. I'm so frustrated though. You do all that work on the car, like especially the first time I did all the ABS brake bleeding and I put all the new equipment in there and I got it all bled and I thought I was good and I closed the hood and the windshield washer tube breaks. It shatters into a million pieces. So I get a kit to repair that and then I do all the brakes again and this time I actually get a huge bubble out of the system and everything feels good. And then I close the hood and the third brake light explodes. Like one thing after another. It's all right. I'm starting to generate fewer jobs than I am fixing. So that's the goal really. Let's see if this light works now. Why is it still messed up? Why? Why do you forsake me, shop? Why? I'm gonna unplug it and plug it back in. I can't fix this remotely. The only problem is when the track lights go out, because that switch is actually in a crawl space. This one I can actually reach and unplug and plug back in. I would have to kill the lighting circuit at the breaker in order to reset that one. That or reach up into that hole in the ceiling. What up, Groovy? Everything in my life is falling apart because I'm a cheapskate. My parents, every time I try to be honest with my parents about what's going on with my car, why don't you just take it in? Why don't you just take it to the mechanic and let them do it? Like, no, I have to be thrifty. There it is. Oh, and it's on. Well, it shouldn't be because we're on, this one doesn't get a, well, now it works perfectly. All right. Bada bing. There we go. Now I got my light. All right. I had a pretty good holiday. My brother got me this thing, which is just fucking inundated with sexual innuendo. Who's your... I opened this thing up, and I'm like in front of his kids, and I'm like, who's your smoke daddy? His kids are like, ew. Everything falls apart on me, even if I don't cheap out. Well, I'm starting to experience that one, too. Yeah, who's your smoke daddy? I looked up an instruction manual on how to use this thing. This is a cold smoker. I was greeted by the creator of this thing, which is a bearded, fat, white guy. I was like, oh, that's That's neat. Okay. Bearded fat white guy apparently makes these smoking products. That makes sense. Bearded fat white guys know barbecue, right? So I look up reviews on this thing. All of the reviews that I could find were from bearded fat white guys. Like, oh, huh. Since you spent the time and effort and did good work to that light, is there anything you could possibly use it for? No. It's just a bank of red LEDs from 1999. Like, I don't fucking need a bank of red LEDs from 1999. I could buy a red LED strip and replace this in this housing, which is something that I've considered. What do you mean AI choosing gifts? Yeah, it does kind of sound like paraphernalia. Like I could load this thing up with like $6,000 worth of pot and just go ham. It's a cold smoker, so all this is a chamber with an aquarium pump pumping air into a blower that pushes air into your barbecue or your grill or your smoking, you know, whatever. A cabinet, a file cabinet that was left on the side of the road, whatever it takes. This does nothing. This is just a handle. I just loosened that permanently. Cap on the bottom just keeps ash from falling everywhere. It's got a couple vent holes in it. You put a piece of charcoal at the bottom, and there's just a snap ring that holds in a grating. So you take a blowtorch to the charcoal, light it up, and then you put a bunch of like applewood or whatever chips in the top, and you have this thing modified into your grill so that it's below it's just above all the catch stuff, but it's below all the propane stuff. And you don't even need to use heat. You can smoke cheese with this thing. So I plan on using this for the pepper haul. This, by the way, the spring is just completely confusing. Why spring? Well, the spring is here just to create an air channel in all the chips so that as they burn, they are releasing smoke into the top of the chamber, and it gets caught by the aquarium pump that's going to then venturi a whole bunch of smoke flow into the rest of your stuff. That top cap's just there for show. Seems fun to mess with? Yeah, it is clever. I feel like I could have built this thing with a tin can. I could have found stuff that would do the same thing as this. You know? I feel like I could go to a junkyard and like get like an air filter box from a like a diesel truck and just make something like this. But it is cool. My brother got it for me, so I'm gonna have to mod this into, I don't know, I guess our gas grill, and then I'll start playing with it. You can smoke cheese and salmon and all kinds of other stuff that's sensitive to heat, because it won't, this won't cook anything. You're better off like with a file cabinet or like something with like that you can put racks in, an old oven. But I'll just throw this onto the side of the barbecue that we have, because it's getting old, so I don't have too many qualms about doing modifications to it. It's just, where is this going to sit? Because you need to be able to get at the top so that you can put more fuel in it, and this needs to sit pretty low, so it's kind of a awkward setup. Thank you guys for the follows. Yeah, anyway, that was kind of the cool part of Christmas, so I'll have fun with this. I'll have fun with this. My brother knows I like to tinker around with stuff. What were we doing, though, before all this whole cavalcade of failures started to plague my very existence? Oh yeah, the other thing he got me was the big metal sign that's sitting behind my face. He actually did a really good job. I did a shitty job finding gifts for him, but he got me the warning electricity will kill you sign. So I'll have to find a place for that. I don't know if it'll be on camera. I have a place for it kind of a little bit off camera, so I might put it there. We'll have to see. I'll have to figure out a good spot for it, but it's a metal poster. All right, brake light stuff out of the way. This is the old brake light. What are we working on? Well, it's a continuation of basically exactly what the title states. I bought a ghost hunting tool. I didn't end up finding any ghosts, though. That's kind of the disappointing part. We didn't actually end up finding any ghosts. Probably because there's too many. It's like the Mr. Burns effect. They're all trying to get through the threshold, and they all just run into each other. Shouldn't ghosts be naked? They don't take their clothes with them. Anyway, it's like a milligauss sensor. Gauss. That would be magnetic energy. It's measured in Gauss. I guess you can also do the whole magnetic, you know, the electromagnetic spectrum kind of thing, where it also relates to radio frequency. And so we're trying to figure out how precisely this ghost hunter finds ghosts within the... I keep calling it a ghost hunter. The people who made this thing do not call it a ghost hunter. They actually don't call it anything because we don't really have any direct literature from the people who make this thing itself. But in and of itself, what this thing is doing is it's reading electromagnetic interference. And electromagnetic interference can be caused by internal oscillators or signaling that's in a device. A complicated device running digital signals will cause electromagnetic interference. It is basically a change in magnetic field. That's it. And we put it into the presence of a coil, and then that changing field, and it could be an electromagnetic field, it could just be a magnetic field in the presence of a coil. As if it changes, that means that it's going to induce current. And so if we can detect that current, then we can turn that into a reading, and we can have multiple different sensitivities. Does it even do that much? I'd be surprised if it did anything at all. We did some work reverse engineering this thing, and yes, it seems to do that. Remember, the people who made the device were making it honestly. It's the people who are selling the device that are listing it as a ghost hunting technology, which is completely facetious because you can't hunt something that doesn't exist. But we want to figure out what this thing is sensitive to. And so I want to get a little bit more characterization of this thing. These wires are about to fall off for the battery, by the way. I'll probably have to resolder them by the time we're done. But I want to get a little bit of, elbow work into this. Elbow work? I want to grind my elbow on this. That doesn't make any sense. I want to get more work done on this thing. So we got to open up MS Paint. We got to go back to our schematic, and we have to make it work. Yeah, grease the paint. That's the one. We're gonna paint the town grease. Where'd MS Paint go? I had a whole window open. File. Oh, uh-oh. Uh-oh. We lost all our work. We lost all our work. I didn't save. We lost all our work. Hold on, I'm opening it up. I think, yeah, definitely. We lost all our work in MS Paint because of the power outage. Yeah, the PSU diagram, that's the latest on this thing, so. All right, we're starting over. I can just, no. You just find, it's like a meme. You can just go find it. I'm not here to sell products. Okay, we got to start over. That's fine. We sort of know what's already in this circuit, so we can work from there. We'll start with the power supply, and we'll just work through it from there. I don't know, man. It was a gift from somebody. Work schmark. We always lose work. So we can start with the 9-volt input, and then we'll work from there. So we know that there is a battery in this system. So I'm just gonna, oh, by the way, a word on schematics. The way that I'm gonna author these schematics, yeah. The way I'm gonna author these schematics is I'm gonna work from the upper left to the lower right. I'm gonna try to keep sort of a flow of things happening in that manner. Upper left to the lower right, as if you were reading a document. That's just sort of the engineering parlance. It helps somebody who's new to the schematic follow along. Now, I didn't post this to the Discord, did I? I probably didn't. Scroll. No, it's just me bitching about cars the entire way. All right. That's fine. The one part of the circuit that we got stuck on last time was an LED that activates once you turn on the whole circuit. And it's just simple. Like it's just an NPN, even though it tested like a PNP. Everything about that circuit told me that it was a PNP instead of an NPN. Difference between a PNP and an NPN is the way you switch the transistor. If you switch a transistor to a positive signal, then it is an NPN. Now, if you provide the transistor with a positive signal and it switches, it's a PNP, positive, negative, positive. If you provide the transistor with a negative signal and it switches, that's an NPN. I think I got it the wrong way around. I'll look it up later. Anyway, let me just put down what I remember about this circuit. So we've got a battery. So we do the typical battery. This is too big. Too big, I say. Like that, like that. Like that, like that. We'll just do 2, and then that ground is always connected. Then we come up here and we go to a power switch, which is, It's actually a latching power button. But I'll do, since it is technically a DPST, DPDT, dual pole, dual throw. The dual pole part means that there's a whole nother switch. Sorry, dual throw. Now, number of poles is the number of switches. The number of throws is the number of locations for the switch to go to. So it is a dual pole, dual throw, but it's technically a button. So really the symbol would be like a button, but it's kind of a switch, but they don't even use the top half. So I'm just getting rid of this. We don't need it. I mean, the dyslexic characteristics of electrical engineering stuff is going to be prevalent. And one thing that I really like to stress in my streams especially is that there's no problem looking stuff up. You think it's in my project folder? It wasn't in the old documents. Let me check. I would have called it something facetious like ghosts. Oh wait, stream? ESP Wi-Fi snarf. EMF ghosts, ah! Oh, we do have it. Oh, good call, thank you. Let's edit it with Notepad++. So here's what I'm gonna do. I'm gonna open this with MS Paint, but we're not gonna use this document. Oh yeah, there we go. So if you're switching with a positive signal, it's NPN, and then you stabilize it by putting a resistor to ground. And if you're switching it with a negative signal, it's PNP, and you put a resistor to positive in order to stabilize it. But here's what I'm gonna do. I'm gonna take what we're drawing here as a completely new thing, right? I'll cut and paste some stuff over, but this is our 9 volts. This would be 9 volt. And this is gonna be our 9 volt source to the rest of the circuit, right? So I'm drawing it like this because, well, that's what's there. I'm just drawing it the way that it is. Because we have kind of like sketch notes going on over here where we've got a bunch of our other circuits and structures and stuff like that. But good, now we have all this. I mean, it's not like we did a lot. It's not like we did a whole lot. But I'm going to steal this because this is the part of the circuit that just turns on when you turn on power source. So that first LED in the sequence of 6 is just simply a power indicator. It's almost completely isolated from the rest of the circuit. So I'm just going to put it like right here where it's out of the way. Now we're starting in the upper left-hand corner of the drawing. This is going to take a little bit of sketching for us to get this to look like something that we recognize. First of all, we didn't know what the 9 volt trace was originally. We didn't trace it from that side of the circuit. I thought I could do a forest for the trees thing and start elsewhere. But the stuff that we have down is good. So let's save as, first of all. Schematic, boo! The schematic came from inside the house. Can't put an explanation. Okay, so that's the beginnings of our circuit. Now we have a quad comparator. Comparators are a function in electrical engineering that basically boils down to just pure painful math. It's just math. It's all just math. It's like motors are just math, but they weigh a lot. Comparators are math, but they're in a chip. You're basically taking the voltage on one end and the voltage on the other and comparing it to one another, and then the difference is the output. You can use that as an amplifier. You can feed it back into itself and make weird stuff happen. That's where you start to get control and transfer functions to sort of dictate what your circuit is doing on the other end. You can get into a lot of complicated stuff. I want to try to keep it simple, but we need to kind of make a structure out of whatever's plugged into those things. And we need to filter out the noise from the rest of the circuit. So there's going to be noise, like as in filter capacitors and stuff like that we just need to log. We just need to put them in there. So one of our best tools is going to be the microscope. Oh God, that was the wrong one. The microscope. The microscope's going to allow us to go through this circuit bit by bit and see exactly where things are connected to one another. This is a very cursed circuit. You will notice that there is no... Oh, that's interesting. Why is that one connected there? Hold on, I gotta investigate something. No, it's just connected for the fun of it. So there's like a ground plane on part of the circuit over here, but there's no ground plane over here. It's as though they perhaps wanted to encourage noise to feed into this thing. Now that is a coil right there, and we have actually traced out that coil. We know where it goes, so we'll figure that one out in a minute. Our battery plus goes directly in to the switch, and then the switch is swatched to this trace right here, and it goes into R10. And I believe we've already looked at R10. Let's take a look at R10. R number 10. Which one of you? Show your face, R10. Oh, I didn't log which one is R10. I didn't log the R numbers on it. Okay. I think it might be this one, but let's just double check that. That is just the wrong... Ugh. Nope. 7501, and it goes into that transistor, which goes down to that transistor. Oh boy, it's already starting to get ridiculous. Well, let's just trace out our 9-volt line. Let me get a pointing device. I got a little thing over here. What's up, Gonad? What up, Gonad? There it is. 9 volts coming in here. Hits R10. Goes to Q6. Q6 is switching. Well, it's switching 9 volts, so that's a separate circuit. But the base is here. Because remember, transistors. Ha ha ha. Transistors. Ha ha ha. Transistors. Oh, you love them. You love them. You love them. You love them. Transistors. A transistor, if you boil it down to the silicon, is going to look like 3 layers of stuff, right? You're going to have a bar. This is basically the symbol that we represent it with when we're talking about the layers of silicon. You're going to have a bar, and you're going to have stuff like this, and these are going to be doped, and it's going to be like piss. It's like P, and then N, and then P, right? Right? And so usually this would be the base. This would be the collector. This would be the emitter. I think that might be NPN that I'm describing. Anyway, whatever, it doesn't matter. And, you know, current flows through the boundary layers, and then it allows current to flow this way. That's all well and good, and it makes a lot of sense, because then the schematic representation of the transistor resembles that in that it has a bar, and it has a collector, and it has an emitter, and there's a base, right? And you can kind of see, you're like, oh, if I just do this, then I've got the PNP right there, right? That kind of makes sense, huh? But then when you get to the surface mount, you're like, oh, it's just a bar, right? The surface mount is just a bar, and you've got like a pin there and a pin there and a pin there. So that like collector, base, emitter. No, that's not how they're organized. They're evil. They're like this. The base is usually here. And then the thing you're getting current from is up here. And then you're supplying it to here. Or no, sorry. The thing you're getting current from is here. And you're supplying it to here. I don't know, man. It's all so confusing. But I don't know why they do that. I guess it just makes sense if you've got this resistor here, the one that goes to power or ground, and you set this up as a typical switch. You would have like power, and then you would have your resistor right there. So you would just put the chip just sitting right there, and then you make your connections that way, right? That's the only thing that I can think of for those, but it's annoying. It's just the way it is, though. You're best memorizing it. Okay, so back to our circuit. This one. So anyway, whatever this transistor is, this is our first stop for 9 volts. We know that we have a 7501, as in 750 with 1 0 behind it. So 7.5 kilo ohm resistor going directly to 9 volts, and then the collector's going directly to 9 volts. We don't have to worry about what's going on here yet, not until we start decoding the other parts of the circuit. So that is, it just happens to bump into here first, which I guess means that if this pops off, it could drain power from everything else. But, okay, so over here, we're going to this via right here. And that's our 9 volts right there. And it goes do-do-do-do-do-do-do, blop. The bottom of this board has some weird, funky decisions going on it, like this thing right here, that really indicate to me that they they were not very skilled in viewing their circuit board from the other side. There's a lot of things that you could avoid to just kind of clean up this part of the circuit. Maybe they don't care, but there's some stuff back here that just makes it look like my first revision of a circuit when I'm looking through it, through the PCB in CAD. But anyway, we're picking it up over here, right? So we're going to do the outside hole looking down this direction, or looking up this direction. So outside hole looking up this direction. I guess this has a secret little via behind it, huh? Sorry, no. Inside hole. Wait a minute. That's not this. If this is 9 volts, this is actually 9 volts. I wonder if that changes my opinions about this part over here. Second via going in this way. It's like all the way over there. Right? Yeah. There's just one here. So that might be this one, in which case 9 volts is only going to like 2 things, which doesn't really make all that much sense to me. Pointy tweezers. Oh, so you can poke through it. I think these are too small for me to poke through. I could like shove a syringe in it. Oh wait, but wait, this little jaunty goes directly across. Yeah, okay. So it's actually this. This is our positive 9 volts here. So then we're going all the way over here to a 4.7K, and this is actually the one from the drawing. So this is R5. I'm going to mark that down just so we don't get lost again. Oops. Okay. Oh, a tweezer blade on each side of the board. That's clever. Never thought of that. I just got good at spatial recognition. And by good, I mean I try to use spatial recognition. Why are your fingers messed up? Turn your heat on. So that goes into the one leg of this supposedly PNP, but the way that it's set up, everything that I know about circuits right here, it's set up with a resistor capacitor pair, because this goes to ground, right? So it goes from positive 9 volts to ground over here. This will charge up the capacitor over time. The capacitor at time equals 0. T equals 0 is kind of a big concept in electrical engineering, especially if you guys have ambitions of going to school for this. You will be doing a lot of problems that start with T equals 0. T equals 0 is like a little PTSD trigger for a lot of my friends. But T equals 0, a capacitor is a short circuit. Believe it or not, this capacitor, in the presence, when wired correctly, in the presence of power at time is equal to 0, all of that 9 volts gets through the capacitor. Now, that'll only happen for like a femtosecond. After that femtosecond, after T equals 0, it will start charging up. And as it starts charging up, it builds like a charge boundary. Same thing that's happening in the transistors. It builds up a charge boundary, and so it resists that flow of current from positive to negative. And if you over voltage this thing, then the leakage will cause it to heat up and explode. No, femto. So at T equals 0, this is a short, but almost immediately after that, it begins to charge. Since this is such a large value, and this is such a large resistance, there's only a little trickle of electrons coming through here. They're just kind of meandering through that resistor very slowly, right? They kind of meander in. So this actually takes on the order of microseconds to charge up and make this line right here positive, which should deactivate this fucking transistor. It should deactivate it. But it has the opposite effect. It has the opposite effect. This thing fades in. I don't know. I don't know what the fuck is up with this piece of shit. Fucking, I shouldn't curse this much at the beginning of my streams. If I ever have ambitions to put this stuff on YouTube, I will have to bleep over the just absolute fucking string of curses that I am emitting right now, because this little circuit right here, has been fucking pissing me off. Is there another via under the cap? I don't think so. No, the cap exists here. Perhaps. I mean, the cap's here. This goes to... This is a different circuit, I think. But that would be what's switching to here. Might have something to do with this. There might be a different part of this whole thing that we haven't gotten into, because we haven't gotten into this area, and I was hoping to get into this area today. But anyway, what I'm trying to explain is, and I think I got continuity between here and this, so I don't know what's happening under here. That goes from there to there. That's a straight line. And then we have one from here to under the cap, and it may go to this same line. So that may be where the disconnect is. That may be what's going on here. Because from what I saw, from what I ohmed out, 9 volts is here. This would charge up with that 9 volts, and it would deactivate the PNP. And it perfectly describes the type of circuit that you would use to fade in an LED, which this does. All right, let me get the multimeter. I got to get the multimeter. I have to answer this question. This is one of the ones that was really pissing me off yesterday, or sorry, the other day, before the holiday. We got to use the power of ohms. Why do I use ohms? Well, I explained this last stream. I'll explain it again this stream. When you use the beeper is testing for diodes. That's all it does. It doesn't give you it doesn't give you enough information about what you're testing in the circuit. Now, if you can't see the multimeter while you're working, first of all, get good, noob. Second of all, the beeper's fine for that scenario. But if you use ohms, you can see resistances. So if you get slightly the wrong pin and you get a nice even resistance on it, you can look for that resistor. And you can also tell if a microcontroller's dead. After that, the capacitor's charging up. If it breaks the charge boundary, that means you've overvolted your cap and you're in for a bad time. Because this is the way that I describe the capacitor is the same way we use them as decoupling capacitors. You use a 0.1 microfarad capacitor, and in milliseconds, you will charge up to the voltage level. But what that does is that saves your complicated electronic circuit from the slow building. I mean, your power supply is going to build. When I say slow, I mean on like the time scale that electrical engineers understand. So when you have your power supply first turning on, it is getting all of its internals up to voltage. And so on the exit of the power supply, you may see sort of a buildup of current. Well, at those lower voltage levels, if you put them directly into your microcontroller, different parts of your microcontroller can turn on at different nanosecond time scales, and that can cause problems. So what you do is you put a decoupling capacitor in there. That acts as a short at first. While the power supply is figuring itself out, your capacitor is saving your component from getting current. That's why you put it as the first stop instead of the second stop on that part of the circuit. And then when finally your power supply is up to power, that capacitor is charged and all that current hits your controller all at once. Okay, anyway, and if there's like a blip in power, it'll also help smooth it. I had the diode melted into my desk, so I've got a little lump right here. I hate it. I'm going to try to flatten it. I have a little diode melted into my desk. There you go. That was when I was fixing the third brake light for my car that decided to crap out. Piece of shit. Apparently a little tiny bit of moisture got into this circuit, and BMW went, this is a forever part. And they decided to not conformal coat this like every other electronics in the car. So the power surge that hit this went through the circuit, and the circuit had been like splitting apart and rusting for a little while. And apparently when I desoldered the diode, it immediately cracked in half. So I put a new diode in there because I got plenty. The diode's over here. And I put surface mount resistors on it, and I sanded down the entire board until all of the copper was exposed. And I made solder traces. It works. It's just that 2 of the LEDs are unrecoverable. I ordered a new one for $40. Okay, so let's use the multimeter on ohms mode. Figure out what else is going on here. So if I take ground, which is B minus over here, boop. I come over to here to the capacitor, and I test right. Let's move the camera a little closer. Test right here, 0.4 ohms. It's I have a 528i Touring from 1999. Yeah, so there's no other connect. If that connection right here, this is probably also ground. Go to B minus. It's not ground. It goes somewhere else. Where does it go? We'll go here. Oh, it does go there. Oh, it does. Oh, it does. So there's more to the circuit. Okay, plot thickens. All right, cool. We got more stuff to do. Okay, you were exactly right. I just lost the thread. I lost the thread of what I was talking about. You're exactly right. So there is more to this circuit. So let's pull this out. Don't pull this out. You'll get in a lot of trouble with Twitch. We'll pull this out, and here there's more stuff. So how do I want to represent that? Well, like I said, no four-way junctions. We're not allowed to do that. So I'm going to pull this out over here. I chopped my resistor. Hold on. No four-way junctions. They're too confusing for our little smooth engineering brains. I'll take that out over here, and I'll make this one a three-way junction. I'm going to start doing resistor numbers so we don't get lost again. So let me just quickly we know R5 is there. I probably need smaller text on these if I'm going to be doing that, but I'll just try to sneak in the resistor values on everything. I can get that in one shot, though. The current limiting resistor for the transistor is R27, and then the current limiting for the LED R26. So R27, R26. So R27. This one's R26. You want these to be consistent, and I'm not being very consistent, but I try to put the resistor number above the value. I'm an expert in KiCad, actually. The one guy in Florida makes KiCad. Or no, am I thinking the wrong one? I'm thinking of SirCAD. I'm sorry. I'm an expert in SirCAD, which I'll tell you, man, the shortcuts in SirCAD are kind of amazing. It's made by like a normal guy, right? Just like one person. And so when you're placing stuff, you're like, place resistor as PR. Like you hit the P button, you hit the R button, you drop a resistor in. I emulate that with MS Paint, but I appreciate using MS Paint because then I don't have to make a specific part to draw stuff like this. Okay, so that's all the R's and the C's and the B's and the I's and the birds and the bees. So let's just see what else is connected to this circuit because we got something new. And so that explains why this PNP actually pops off, why it actually activates. And it might mean that it actually does something instead of just getting switched straight up. So we've got a 3301 that's sitting on the other end of this thing. Well, 3301, 3300, 3.3K. So let's mark that down. This is going in the wrong direction now, so I might want to flip this over, but I'll leave that for a different operation. I mean, I guess the LED is our final stop for it, so it does make sense that we're going this way. And what resistor was that? This is like, this is just keeping us from getting confused later. So that's R28. Makes sense, they're in sequence for whenever they were putting this circuit in. This is how I want to do it. R on top, and then 3.3K value underneath. We'll correct this one. For consistency. I want like a decently nice circuit because that helps us analyze, it helps with the analysis later on. Because if you follow your own conventions throughout the schematic, then you can make assumptions on those conventions that will allow you to better analyze the circuit. Like, for instance, well, the resistor value is always in a stack and that kind of stuff. Like the text that gets a little too close. I don't know what this one is. Oh, 16 volt. I'm gonna write that a little better. There you go. I don't really necessarily need the capacitor numbers. I mean, if I was doing this as like a professional document, yeah, I should have the capacitor numbers, but they're notable enough that we can find like a 220 volt, 16 volt, a 220 UF 16 volt cap. I can find pretty quickly if I locate R28 or R27. So anyway, moving along. Here we are, folks. We're in the meat and potatoes of this whole thing. We're getting it done. We're doing work. Interesting. What are you doing? Well, this leads to all kinds of other stuff. What is R8 doing? What the dog doing? R10 is where our 9-volt comes in directly, and then that goes over to some bastardization of that part of the circuit, where we have double horizontal jumps, goes there, there, and somewhere over here. So what is that? Well, okay, so R28 is connecting to Q4. Oh, maybe I should... N5 must be an NPN. So the Qs they left for PNPs, but the Ns are NPNs. I get it now. I get it now. We are currently in pursuit of Q7. Mark that down, make sure we have that. Yeah, can you read a title? This it's like an EM meter. Very cheap. It's like $27 device that you can buy. You can hunt ghosts with it, or we're trying to figure out what you're actually hunting with it. So we're trying to get to the nitty-gritty of the circuit. We want to get all the way down to brass tacks so that we can analyze the different parts of the circuit. That's why we're going through trace by trace, and we're trying to just jot down everything we see and know here. Because if I don't, I'm making assumptions. Like, for instance, this PNP circuit that I thought was an NPN, because it had to be an NPN, because when you turn this thing on, this LED just sort of gradually lights up. Turns out, a little bit more complicated. The part that is controlling the base of that transistor is surreptitiously, I don't know, it's very sneakily connected all the way over to this 3.3k ohm resistor that is connected to this other Q4. Q7 to Q4, that's kind of a jump. Anyway, Q4, it is connected to the collector. The base of Q4 goes to, dear God, where the fuck is this thing going? Over to an NPN. Is this an unstable? This might be an oscillator. This might be an oscillator, to be honest. But again, I'm making an assumption. So 3.3 goes over to this branch. What is this branch? I'm going to look around for this. Is this a ground? Well, it's 100K through that to get to ground. Yeah, 100K to get through that to ground. So it's just like a big branch of the circuit then. What the heck? It's definitely not power. Double check that it's not power. Wait, I don't even know if this thing's turned on. I think it's turned on. I can test it over here. Yeah. 3 kilo ohms. Wait. 3 kilo ohms. Okay, 500 ohms. So that's not... I'm just making sure that that's not... And if there's a big capacitor on it, it might actually charge. Okay, it's not displaying that property. Okay. We know a bit about it. Not a terrible amount, but we know a little bit. All right, so things are getting a little weird because we've got... This is switching that. The base is here, connected to that, going up here. Yeah, there's some weird stuff going on here that I need to untangle. The involvement of this transistor and this one and this one and this. Good God, this is getting weird. All right, well, I guess I just gotta start hunting down all the different connections and just getting them on paper, and then we'll clean them up later. So this would be the collector of that one. It also connects to this via. It also goes up and over to 3.9K, which then goes to our comparators. This is a big trace. I'm wondering how much of this we already jotted down on the other part of the circuit. Okay, so this via right here, Which one is that? So 1, 2, 3 are connected. Those down that row. But we are next to that. So we're right there. We're going down here. Oh, God. Oh, God. Down here, so we're above the Zener diode. I don't think we're here. It might be this. No. This is getting crazy. I'm gonna have to just like ohm this out. Well, okay, wait. 1, 2, 3. So we got 1, 2, 3 going left. 1, 2, 3 going left. We were 1 in the 1, 2, 3. We were 3 in the 1, 2, 3. 1, 2, 3. Yeah, so that does go down here. And so we got 1, 2, 3. So it's left to right. 1, 2, 3. We're number 2. 1, 2, 3. I can't believe it. Why are these two why are these two the same? Wait a minute. What even? Hold on a minute. 1 and then 2. So from the left we have 1 and then 2, and there's absolutely no fucking reason why they couldn't be connected to one another. Aside from the fact that it might manipulate your antenna a little bit, but this is still acting like one. You just have this funky trace right here. What the hell? Getting this thing organized is going to be a trip. This is starting to become a very strange circuit. Why would you do this? Here, another method for doing this. Now you could also take a picture and then you could overlay it on top of itself, but like if I take this over to the light, he has one of his easiest times seeing it because I'm not going to focus the cameras for it, but I can just basically look at the shadows of the traces coming through and see that that one is connected. Yeah, that one's definitely connected to the coil, and then this one is connected to that line that goes up. Why would you jump that? Why wouldn't you just connect it here? Oh my God. So stupid. All right, so that is the way that it is. So this thing is actually connected to the Zener diode. What does it hit along the way? There's a lot of other stuff in there, though. Let's just start marking it down. Just start marking it down. So we've got the Zener diode here, and that'll move. We'll have to move it. And the Zener diode also goes to. Sorry, I keep switching to the wrong scene. So Z1, obviously Zener diode, right? Mark that down. I don't know how many volts that is, but it kind of doesn't matter at the moment. Z1 goes down to one of the grounds. There's like a weird ground junction. Look at that. 2 grounds coming out of that thing, going down and around. So I'm just gonna mark it as a regular ground. I'll just count that as a normal ground. I don't think there's any purpose to that aside from making your circuit less stable, but I think it's going to have an infinitesimal effect. German word Zener diode. Zen stands for 10. 10 volts breaking voltage. Well, the thing is, Zener diodes, what we generally do with them is we hook them up backwards, because the chart with a typical transistor, what you would have is... Okay. What you would have on the chart of, what is it, like V, and then current, as your transistor gets to the switching voltage, it kind of has a chart that looks like this, right? That's a normal diode, rather. Sorry, this is a normal diode. So as you get to the voltage, the forward voltage or the reverse voltage, suddenly it allows infinite current to run through it. But if you have a Zener diode, what it's going to look like, I believe, is it'll just be like a wall, and then it comes through like that. I have to actually open the chart up to do it properly. And the whole purpose of a Zener diode is to control that voltage where there's that wall. See, you've got a leakage and a reverse voltage. So the point is, if you hook it up backwards, what it will do is it will regulate the current in that circuit to be at that voltage. And it's a little lazy to do stuff like that. You should typically have like a current limiting resistor on it so that you're not blowing up your electronics. But you see in a lot of 9-volt circuitry, you see a lot of Zener diode stuff going on. But the whole purpose is to current limit. Why is that opening another one? Sorry, voltage limit. What the fuck? Wait a minute, what happened to all my MS Paints? Did they all just close? What the hell? Why did my MS Paints just close? Oh, no, they didn't. Okay. I was like, we were in the middle of working on this. I'm gonna go ahead and Control S both of these suddenly. Control S. So yeah, the first notable stop is that Zener diode, but there's more stuff. So we got to note down all the stuff that we see, and then we can rearrange things in order to make it all make sense. So what else is stopping in at this positive juncture? Well, we've got C2 and C1, big capacitor, small capacitor, and those are generally power supply style things, although they might be here to stabilize the coil. So we're going to mark down C1 and C2. So I'm going to get this out of here. And we'll just make a little gap right here, and I'll put, we'll put C1 and C2. They're both electrolytic capacitors. So we'll just put them next to the Zener diode. Small cap, big cap. We're smoothing something. We'll be polite and put the plus on it. So C1, C2. I'm not going to mark down the values of those. We'll probably need them later, but I'm just not going to do it. So I got C1 and C2, and that's going to complete that little branch, although C1 goes into some kind of an infernal Q1. What's happening there? We got 330 ohms going over to that junction there. That one goes back to what we had before. Oh boy. Okay, so actually C2 we're going to have to take away. C2 I'm going to move over. What's up, BM? Oh, yeah, I got to plug back in the fart box. Speaking of BMs. Plug in the thing. Okay, there. That'll log in a minute. Gotta give it a minute, then the farts will work again. All right, so we got more stuff going on here. Let's rude. Let's figure out what's going on with C2, because C2 is doing weird stuff. So C2 goes from that junction at the Zener diode, and I don't know whether or not I want to. That part of the circuit seems to go to places that it's not involved with. It goes to a bunch of that you know they don't seem very relevant to what we're doing. It's a strange junction. We got R3 and R6. R6 goes off in this direction. R3 goes off in this direction. They're splitting up. They're going all over the place. The negative leg of C2 goes to 330 ohm kilo ohm resistor. This, which goes here. What the hell's that thing? That's our coil. Okay. But that is at that's Q1, and it's a Y2, so it's a PNP. And so that's the top of our coil, goes through a PNP that is switched by what we're looking at right now, the end of this thing, and this going to here, which might not be ground. No, it's too short of a, there's no vias on it. So not ground. We got 330, and that goes over to here, and that's not ground. That's like some kind of a source. This is getting more complicated. No, it doesn't do that. It does not store farts. Seems interesting topic. This is an EMF detector circuit, and it's a little bit complicated. Now, I'm going to do something in a little while that might just shortcut the entire thing. We might be able to just find this circuit. It doesn't seem like it's something that would be that difficult to find. But what I'd like to do is just get the circuit together from nothing and figure out if it looks like something. So anyway, let's just go in the vein that we're just hooking stuff up. I just want things to connect to one another. We can make it make sense later. As I work through this circuit, I am trying to organize it into structures that look like something an engineer would know what it looks like, right? But we can't always do that. We don't always have the whole picture in one glance, and I personally don't have the memory capacity to keep this all together at one glance. So anyway, we're still working on this like mega junction up here that we don't know what it is, right? We don't know what this is, but it makes a lot of stops along the way, including an enormous coil. And that's this right here. This is one part of an enormous coil that actually ends on the other side of this transistor. So this whole part, I believe, is some kind of like an RF circuit, which those get a little crazy. And I'm of a mind that I kind of want to split off the Zener diode part of the circuit so that, well, I mean, we're already here. C1 is like way off to the side though on that positive thing. So C1 off to the side. C2 goes to the transistor that gets to the other part of the coil. And then right at that Zener diode, we've got the big coil. So I don't exactly know how I want to represent this. I mean, I can just go, oops, that's the wrong tool. Big coil here. We drew this last time, so I'm like somewhat in the know of how to draw it. And I'll have to characterize that later, but so the other side of that coil, other side of the coil goes to this, and I'll put a circle. I'm just going to draw a circle on the end so we know which end is which. Put a dot on, you guys can't see this, but I'm putting a dot on the other side. Basically, all I'm doing is marking down the schematic in such a way that it communicates to me what's there. So then we've got this transistor, and the base of this transistor goes towards the circuit that we're looking at, which includes C2. So I guess I can draw, because the collector, okay. I think, wait, which one's the emitter and collector on a PNP? Hold on. I need to know this for me. It's just so I can talk about it properly, because I think the emitter, yeah, the emitter is at the top. So I was calling that the collector. For the PNP, you call it the emitter. And this is part of the EE 101 strategy to just confuse the ever-loving fucking shit out of you. So this goes to the admitter for admission. Oh, I held down shift and it made a straight line. We can't have that. So the emitter, the emitter. This is the collector, and then the base. Now this is where it's going to get a little weird, because actually I should probably draw it below, just for cleaning it up. We'll work on that in just a sec. Hold on, I'll tell you why. Because C2 goes over here, and it goes up, and it goes over here, and it goes down, and it goes over here. And then it connects to the collector of the PNP. So C2 and that part actually connect to one another, which would make a little bit more sense for us to put that if we're drawing it like this. And again, all this stuff can change, but I think this should go down here. So let's take this whole thing. Well, how does that work? I'm not going to flip the transistor. I guess I could flip the capacitor. I could do that. The base goes towards this part of the circuit. Yeah, okay. When I draw these, I generally try to minimize the amount of lines that are crossing over one another. That takes a little bit. It takes a little bit of doing and know-how to get done. If you get all your stuff down on paper, at least that way you don't, well, that way you can start rearranging things to fit. Now wait, is there anywhere else that this is going? Yeah, it does go somewhere else. So I'll do I hate doing these, but upside down capacitor. Actually, we can do, yeah, upside down capacitor here. We'll have to make that look better at a later date. C2 connected there. And then we've got R2. Oh God, Q2, R2, where the hell? Q1? Wait, we're working with Q1 right now. Yeah, so this is, let me just mark that as Q1. I'm gonna guess there's some oscillating things going on here. Oops, I marked that Q2. I'm not thinking. Not thinking straight, chat. Q2, negative leg, goes up to 3.3K. That goes to Q2, which does not go to Q1, but it does switch something to Q1 on the emitter side. Wait a minute. Okay, sorry, I think I messed something up. Z1 connects to there and to there, which is the dumbest thing ever. That also goes up to where we were. So up to here. 3.3, the other side of 3.3 goes to Q4, which we haven't done yet. Oh, this is when it gets kind of like this is when I start to get confused and it gets complicated, and it's good to go for a cup of coffee. But we don't have coffee right now. What's up, Pyro? So anyway, these two are connected. We'll get that via later. That goes to these two. Goes over to Q2. The association that I was trying to make is that Z1 branches down here, goes to the positive of C2, negative of C2 comes across, and it goes to Q1, where it's switched with the dot. So the dot goes here, and then the base of Q1 goes all over town. Jesus Christ. Streamer. Well, we're just getting into the meat and potatoes of this thing, and I'm starting to like confuse myself, so I gotta be careful at this juncture. So okay, let's go back. We're going back to Q1, so we're at Q1 right now. We have C2 mapped out. We know that C2 goes to a 3.3 kilo ohm resistor as well as Q1, but on Q1, the collector, sorry, the emitter is connected there. The collector, okay, that was the base. Oh, that's what, okay, all right, I get it now. That's where I'm messing up. I got the wrong branch of the transistor, sorry. These are little things where, like, if you get it wrong, you can really confuse yourself and, like, lose your place in the circuit. So actually what I want to do is, let's just get rid of all this. Let me just draw this back in. And then I'll just go like this. Oh, hold on. That was bad. So it's a little weird, but the coil will go like here. But we'll associate it with the Zener diode and stuff. We'll just move it kind of close to that stuff. And that way my capacitor doesn't have to be reversed. I'm going to draw that again because I'm mad at it. So then I have this coming up here. And I've got my capacitor. And this one is C2. That goes to Q1 and the base of Q1 and then the emitter of Q1. And the coil connects here, confusingly. Because the coil's with Z1. The other side of the coil is the dot, which goes to the emitter of Q1. The emitter of Q1. And then the base of Q1 is what goes to this 330 and then the capacitor. So at that capacitor, I actually kind of wish this was a little tighter, to be honest. Because I want to communicate that this thing is a like C2 would have. Well, I'll just draw it the way I'll keep drawing it like this for now. But we got a resistor here, and that goes somewhere, and that goes. It's a 3-point. It's R2. Beep boop boop wheel R2, and that is a 33000. So 33K. Why did that take me so long? 33K. The values of the resistors are kind of important to me. The values of the capacitors, not so much, but I'm going to put 22 off below C2. Because it is some kind of a timing thing with these two charging up. Why is the negative on the... Oh, I got that wrong. Wait, no. Okay. That's not here. That's down here. Sorry. Bop. This is actually what we got. 33 is on the bottom part. On the bottom part of the base. It is not up here. There's other stuff up here, but not this. So right now, oh my god, there's so much crap going on in this area. It's going to resemble one of those circuits that you look up that's like a Circuits 101 circuit. I don't know what this whole junction here is doing yet. But for some, you know, this being a PNP makes sense now because there's other stuff going on over here. And that's somehow going to be involved in some kind of I think what's going on over here is that this is going to create some kind of an amplification of whatever wibbly EMF gets into this coil. Yeah, there's other stuff connected to that transistor. That was the thing that I just discovered. Collector to multiple things. So that's the other side of that circuit. The emitter goes to this part, but the collector goes to a bunch of stuff. I got a bunch of stops for this thing. So those are all going to negative. Oh, thank fucking God. Thank God we found a negative during all of this. I thought there was no hope. Apparently this is negative too. So negatives all the way down here. Man, digital electronics are so much easier. So the collector of this and the collector of the other transistor and the 3.3, no, the 3.3K is on the other side of that. Oh my God. I think, okay, so Q1 goes, okay, so here's what I'm going to draw, what I just saw. This I'm going to go all the way down below this resistor, and I'm going to put in another transistor. And that transistor, I believe, is going to be... They're both PNPs. The base is what we are drawing. So the base of that one. Okay, so I believe that we can draw it like this. And I'll have to check my work on this, because I haven't really totally verified it. There's a resistor there to ground. Now that might loop around and connect to part of Q1, but let me just verify that those are the connections that I've got. So the base is connected to Q1's emitter, correct? And that's at the that's what resistor is that? R1. They started the circuit here. R1. That's Q1. This one is Q2. So I'm starting to see a transistor triggering a transistor, as in creating a wibbly wobbly circuit element. Hold on. This would be R1, Q1, Q2. Yeah, we got... Oh, yeah, the value of R1 is 2002. So that's 20000. So 20K. 20 kilo ohms. Okay, output of Q2. Oh, wait, also there's a capacitor on that. So R1 is in parallel with a capacitor. So I'll just draw one of these, go over here, and put a ceramic capacitor. We don't know the value of the ceramic capacitor. We could guess, but we're just going to call that what it's called on the circuit, C3. What's up, Kervos? So, what am I seeing in this circuit? I don't know. But we've got some kind of like a triggering a trigger. I suppose you could say this would be like outlining stuff, but yeah, Return of the Ghosts. We got ghosts, chat. Okay, so we'll just keep marking this down. I mean, if I look up like oh, I don't know, RF transistor amplifier schematic. Just simple stuff. There's a lot more like coilage going on in these things, but let's see. Where do we have transistors talking to transistors? Yeah, something like that. Kinda. Yeah, you kind of have like an amplifier structure here that goes into another amplifier structure here. I mean, there's also like the transistor, which I don't think we have here. I don't think we have a transistor oscillator, but you start to see structures in things like a transistor oscillator that sort of start to insinuate the circuit that we're working on. Things that look somewhat similar. Not quite like this, though. It's always rough when you have a transistor oscillator because you try to draw it like you normally, hello, Zener diode, like you normally would with, you know, the transistor structures that you normally see. But there's a weird crossover about transistor oscillators, and you end up having like a circuit junction that like jumps up and around, and you're like, wait a minute, and you have to draw it like they do with the two transistors talking to one another. It's always strange when you run into a circuit structure that you don't recognize. Let me tuck you guys in a little bit more there. Okay, so we'll take a look at that stuff later. This is the wrong one. So what we're trying to do is figure out what in the hell it's doing with this coil. Now we've got some kind of a line here that we haven't fully vetted out, so I'm actually going to draw a dot and just keep going out that way with that. I want to finish up what we're doing over here with Q2 and Q1, because they're doing something with a coil. We kind of ran into this because I was looking at what this circuit specifically, the one that's involved in the first green LED right here, what exactly is going on with it? Because this was an NPN transistor, and according to what I saw with the capacitor and the resistor, this very much resembled a way that you would have an LED fade in. So it would literally just be a circuit that was there for when you turn on the power switch and the LED fades in. Well, electronics being what they were, we ran into all kinds of weird stuff. We have some kind of power regulation and or RF shenanigans going on with Z1 over here, where it's bleeding off any excess voltage. Then we have an entire coil hooked up to a couple transistors that might even be amplifying the signal, but they're using this original. I don't know what's going on. We're going to have to investigate this more. I need more information on this thing. Not to mention the stuff that we got yesterday with the amplifier circuit. But we're getting there. We're getting there. So, luckily, this part is not associated with this part, but we will get to this upper part of the circuit in just a minute, where it actually goes and talks to the operational amplifier. This is kind of the perfect circuit for us to work on. I hope you guys are satisfied doing this today. I hope you find it interesting, because this turned out to be a 3-course fucking meal. I did not expect that. The one that Illuminati looked at was one, and I would need a reminder about the video that I was watching, but it was Illuminati. She did a video where she was talking about ghost hunting and how these ghost hunters are kind of a grift, which is all well and good, but she talked about a couple different cheap ghost hunting tools. I looked them up. The other ones are like hundreds of dollars, so I'm not going to buy them. Unfortunately, I'm not going to buy them. This one was $27, which is a little expensive for a stream. We're getting multiple streams out of it, though, so I think it's a good investment. But I don't have money. I don't have any money, guys. God, I'm so fucking broke. Car parts like emptied my account out. I have no money. But it's right up our alley, because the one that Illuminati, Nauhty, looked at, or she found a YouTuber who reverse engineered one, and I'm like, that should be me. She found a YouTuber that reverse engineered one. The one they reverse engineered had a part in it that's literally just EMF detector, right? It's an ASIC. It just has one purpose. Well, we found a general use operational amplifier. It changes everything. That means that we are now into the world of radio frequency analog electronics that involve transistors. So this is getting into some of the weirder parts of electrical engineering, and I think we can really sink our teeth into it. So that's what we're working on. This has become the bane of my existence for a short amount of time. Burn the Subs is, of course, sitting behind me. We're waiting for circuit boards on that, and we can work on a bunch of stuff with it. But I think this is a good holiday project that gives me something to sink my teeth into, and we can have fun with it. So, boop, back to this. So we've still got a lot of aspects of this thing that have not been vetted out. I'm going to take this part of the circuit that we just drew, and I'm going to take it and I'm going to move it over, because we're adding more stuff to it. It turns out there's a whole story to be happening here before we get to that green LED. So let's take a look over here. So on the collector of Q2, it's confusing because Ben Franklin got it wrong. It would have been better to, because like the collector collects and then the emitter emits. It doesn't really hold out. Anyway, the output of Q2. Now this is a PNP again, so we'd have positive voltage here, and the more positive it is here, the more current gets to flow through. So C3 and the 20 kilo ohm resistor, well, that would start as a short and it would charge up until, well, no, it would discharge through the 20K. So whatever the hell's going on there, this would switch and provide current to this part of the circuit where it would dissipate out. C3 would just smooth it out a little bit. C3 is a ceramic capacitor, so positive or negative doesn't matter to it, but it would maybe feed back, and we'd basically be overcoming the 20 kilo ohm resistor with this part of the circuit. Okay, well, let's figure out what Q2 is doing. So Q2, the base of Q2 is connected to Q1. I have that right here. As well as the RC combo. And that's sitting, where's the board? Okay, I couldn't find it. So yeah, here's our RC. Hold on, I gotta get my pointing device. Pointing device. So we got an RC connected to ground, sitting off of the emitter of Q1, the base of Q2, the emitter of Q2, and then the base of Q2 going... No, wait. That emitter... Oh, yeah, the base. We don't know where the base goes. I made an assumption that it went over to the base of Q1. Which one's the base of Q1? That's here. That's not where it's going. Okay, so it goes here. What? Huh? Hold on. Q2. Oh yeah, that is just, it's just making a little jumpity jump. So this is just going from here to here, which gets us to N3 and another RC. Oh my God. So the 33K going to... which one is that? Okay, hold on. Collector, or no, the emitter, whatever, the top one, and the base going off in this direction. Okay, that's correct. And the emitter here goes to an NPN. So this goes to, what part of the NPN does it go to? NPN. I don't exactly have the bandwidth to deal with everybody making that same comment. So that goes to the base. So it goes to the base of an NPN. Which is, we're going in the wrong direction here. I'm going to draw it this way, but... You a band fetishist? And what queue are we on? N3. Oh, please don't punish me. I would very much enjoy that. Okay, so where's this going? Oh my god, it goes fucking everywhere. There's an RC on the base. Okay, so we at least have that going on. So we grab, oops, sorry. So we grab this, and I'll take this. Now this is, remember, this is our first draft, so we'll take all these structures and we'll maybe try to clean them up later, but... And a capacitor, and it's a ceramic. Probably should have done the other order so I could actually put the text in there, but that's okay. 1000, huh? R4C4 10000 10K. 10K, and probably that's probably a 0.1 to be honest, but who knows? You know, you can't, there's no value written on that. So C4 R4 10K. We'll clean that up if we need to. So capacitor and a resistor again. We're stabilizing something. Each branch of this thing has that. Then we go to our first NPN transistor, N3. N3, which is so hastily marked that for some reason, in spite of all of the other components, at least, okay, give me this freaking tool. At least most of the components have the thing right next to it, right? It's like not that far away. This one's a little bit, but this one's like all the way over here. Why did you put that much space? So that one is connected to this junction. Got an RC to ground over here. Why it's over here is beyond my reasoning. It is also associated with the collector of the other transistor, or rather the output of the other one. Wait, I thought that was the input. That's the output. No, is the output? Yeah, input, output. Output, yeah, okay, yeah. Yeah. So that's the base of the NPN. Now we're actually starting to get back to where we were before. So now we've got most of this stuff figured out, except for this stuff over here. So most of this stuff is starting to pan out. So let's get over to this other part of the circuit. This is going to be kind of complicated, and it'll be a little difficult to analyze. I don't know. There's so few NPNs on the board. Maybe they just decided that they would differentiate them. I mean, usually you would just put them in the queues. Just drop it, man. Nobody cares. Just don't worry about it. You didn't do anything bad. Jeez. All right. So we are over here, and I'm trying not to let chat get me distracted because they're fucking weirdos. Weird people in chat. Anyway, so N3, we figured out where it sits on this whole weirdo situation that we're trying to figure out. This really led us down a goose chase, didn't it? But we've almost got the goose, I promise. So there's a 10 kilo ohm resistor on that to the collector. Actually, first we got the base. Let's get the source of whatever this thing is switching. Now that involves whatever the hell this thing connects to. I need to make sure that that's not like our positive power trace, because it might be. That would simplify things a lot, and I could ignore other parts of the circuit if that were the case. Let me just figure out whether or not this is... So we're talking about... what are we talking about? Talking about dub. We're talking about dub. We're talking about this channel right here. 15, 16K. We are not associated with this part right here. The IC on the board is a quad operational amplifier. And I already went over this last stream, is that when you go to reverse engineer something, the chips are basically going to tell you the forest, not the trees, but if you look up basically the appropriate way to reverse engineer something is to find out what your chips are first. And if they're not obscure or obscured, then you can get a lot of the operation of the circuit. Now, we found quad op amp, and I did a little bit of reverse engineering around this area. Confusing. We need more of the circuit in order to figure out what's going on. We did find the big meat and potatoes of the whole thing. This is all about the coil. We're all about operating this coil, and this coil is somehow going to dictate basically everything that's going on here. So we're going around this area and we're getting all this stuff done. This is work. This is real work that we need to do here in order to figure out what's going on. The NPN transistor, right? We got the collector up here and we have the emitter over here. Now the emitter is going to parts of the circuit that we recognize. We know this junction here and we know this junction right here. That's 3.3 kilo ohm that goes to the negative lead of C2. This is looking like something that I've dealt with before and I can't put my finger on it. Can't quite put my finger on it. So we know that this lead here is associated with more of the stuff going on. Where does that go again? So that goes to 3.3. Wait, is that the same one that goes there? Yeah, that's at 3.3. But that's another 3.3 kilo ohm. Sorry. Yeah, 3.3 kilo ohm. That's R3. And that connects us to, what the fuck? Hold on a minute. Things are getting confusing. So from Q1, and I'm looking over here. If I could have both of them on the screen at once, I would. Actually, I think I can. Okay, not quite. That's the wrong computer screen. That's wrong. Well, I can move it over here, and then I'm going to look like I'm looking at my belly button, but whatever. Oh, wind's howling. Wait, that's the wrong window. Hold on. Minimize that. Oh, no, that was a truck going by. All right, so that's a small window into the circuit, but at least I can take a look at stuff and dictate it to you guys. All right, so this is R2. We're talking about R3 that we haven't put on the board yet. So R2 from the negative lead of this capacitor of C2, right? Yeah, C2 negative lead. C2 negative lead right there, up to R2, 33K, goes to the transistor. It does not actually connect to this part of the circuit. Wait a minute. Do I have something backwards here? Okay, oh, it's the other side. Okay. That's this right here. And that connects to... Well, no, that goes to the other side of Z1, so that actually goes like this. That's R3. I swear I've seen something like this before. What was the value of R3? 3.3K. What am I hitting Control Z on? Why? Wow, that's a big jump for this to make. All right, that's fine. See, the thing is, I don't know what this is, and I don't know what to call this. This is just like another junction. And you can actually clean that up quite significantly if you name it something and just use an arrow to go to it. But I'm not doing that yet. We're not at that point. Where can I read more about this alleged ghost hunting device? Random eBay listings, an actual brand. No, I don't. If there was an actual brand, we'd have literature. It's just like an EMF meter. No, I have a pad. Chat sent me a pad. Much to great expense, and I feel bad that I don't use it because it's not that useful. This is not the one that I have, so I guess I'm okay with you linking it. Yeah. Don't, if you find something where they're reverse engineering this, I do not want you guys to link to it. Very specifically, I don't want you guys to link to it for the reason that the exercise today that we're doing is more about learning how to reverse engineer something when you don't have any information about it. We're not looking up the device to find that somebody else has already done all the work of organizing the schematic, because then we just control P the answer. You guys ever play like a video game? You guys ever do that? You guys gamers? You ever play a video game that you, like a single player game, and you just decide to cheat, and suddenly the game, you lose all interest in it? We've done that intentionally to games we've played just so that we don't play it anymore. So please, and I'll reiterate that it's not for any specifics, but I mean, Wayne Johnson got ridiculously close to posting exactly the device. This is not that. That's why it's interesting. This is not that device. That device has a chip that's specifically for EMF reading. We have a quad op amp. It's different. It's a different circuit structure. I guess maybe cheaper. So most of this goes over my head, but the subject's interesting. You'll find that there are many gaps in my knowledge as I go through this. And as I talk about circuit structures one way, find a new piece of that structure, I'll talk about it another way, because all of my information has changed, which is happening with this LED circuit. We ended up on a wild goose chase throughout almost the entirety of the rest of the circuit. So as we get there, there will be big gaps in my knowledge about things that I don't know. And if anybody posts like the direct schematic to this thing, I will delete it, because that's not why we're here. We're here to figure this out ourselves. All right, back to what we were doing. So we're just trying to get this area of the circuit, and this is, I'm drawing this as kind of like a tall piece of the circuit. There's possibility that maybe I could clean this up later. Right now, as I see it, I'm just doing like something akin to a rail-to-rail schematic. We'll just see if this you know, opens up to something else. And then as we move through this, we can actually, we'll be able to look up individual parts and see if we can rearrange them in our heads to look more like schematics that we can find on the internet, explaining how to, for instance, read from a coil. Does this thing have an input of sorts? Yeah, you're looking right at it. It's a coil. Most of this circuit board is a coil. There's a big coil running around the perimeter of all of the circuit pieces. And that's going to be our start. Even though right now it's not drawn as the start, we'll have to figure that out later. So right now I'm going through this as sort of a free thought or whatever, just write down whatever, you know, if it's there, write it down. So anyway, we are at N3, which is the, what was the mass effect number? It was like N4. So N3, this one right here. We have the collector. Well, this is the base right here. And that junction goes over to Q2. So we've got that part of the circuit. And we have the resistor capacitor that's for some reason all the way over here associated with it. So base right here. Which one is emitter and collector? Emitter, right? The collector comes from all the way over there. The emitter is then going to things that I recognize, like Q4 and N5. There's more to this. Oh my God. Well, here's our big junction. And that gets us to Q2 like that. That gets us to Q2 there. And then this is on the other leg. That's the emitter of the NPN. So R6 does a big old loop back then. Is that a trace under the R? Yeah, I believe it is. So R6 gets us all the way back. Jeez. So that would be, but that's the emitter, because surface mount transistors. I got to write this stuff down just so I know it, right? This is how these things are internally wired. Okay, so I'm gonna drag that back over here. Look at my little thing. Oops. Go back over to here. Okay, so my brain. R6 goes from that rail to the God damn it, my brain hurts, chat. I gotta open up the other paint drawing at the same time. Oh, so that goes to the collector. Wait a minute, I could have gotten one of these mixed up. I'll have to double check that in a minute. Oh no, but the collector's the output of the PNP. It's the NPN that has it. Yeah, okay. So the collector is on this side. So this that cleans up our schematic a little bit. So that'll do this. Oh my god. That really needs a signal arrow on it. Ugh, it's terrible. And this one is R6, and it is 10000, so 10 kilo ohm. R6, 10K. R6 10K. All right, so that rounds out that area, luckily. We got more that's going into this part of N3, but let's get the other part of the other side of N3. I want to see what it's outputting to, because there's more stuff that it's inputting to, that's for sure. Or that's inputting to it. That's inputting to it. So I'll mark that down and just make sure that I know that there's more stuff there. So just put a dot and put a line coming out of there. I know there's more on that side of that NPN. So on the output of that NPN, we've got the first thing it hits is a frickin' via. One of these evil fucking vias that I don't know where it goes to. That one vertically, doesn't that go here? Why would it just go to a ground? What is your problem? No, that one actually, wait a minute. We're talking about this one, the bottom of the 3. The 3 going like this, we're at the bottom, so it's going to the left. So, that goes here? No, it doesn't. Wait a minute. Does it go to the right? Oh my god, I'm so lost. Are you my grandson? 1, 2, 3, in sort of a little swoop. 1, 2, 3 in a swoop. There's the via. It goes to the left. Oh, it goes to R8. Goes to R8. Who told you could go to R8? What's your problem? What do you have against me? What do you have against America? Okay, so that goes to R8 and it goes to R9. R8 goes to N5. The base of N5. Oh my god. So that would be down here. R8. And that one's N5. We'll do it actually in the right spot. Now it's going to start looking like chaos as we get more into this design. That's just what happens with this sort of thing. It gets more and more chaotic, and then we kind of rein it in from there. There might be a time when we just have to do a little bit of soul searching and just kind of take a break from this and take a walk and then come back and then go, oh, okay, I recognize what that looks like now. That's the mystery of this kind of thing. We are solving puzzles. We're solving puzzles. I've been talking to my dog too much lately because I always call her Bubbles or Bubby, and it just translates into muscle memory, and so I end up calling things Ubble. Anyway, this is all puzzles, but they're real world puzzles. We're trying to get into somebody's head. We're both trying to get into somebody's head and try to figure out what their source material is actually. Okay, so N5 is all the way up there. This circuit that connects to the base comes from, it's got a lot of places to go. So we may need to move the whole circuit over again. I lost my bottom bar. Where is that? What? This isn't the whole page? I know there's more on the page. Why doesn't it let me move over? Oh, MS Paint. You scamp. Oh, it's because I didn't move the window over to begin with. Haha. All right, there we go. So, well, I guess I got enough room. Okay, so let's move this over. So R8, yeah, R8 just to N5. It also goes to Q4. The emitter of Q4, what the hell, man? Where are all these transistors coming from? Or the which part of Q4 is it connected to? It's connected to the part that collects, I believe. I'm gonna go to my drawing of the transistors just so I get this right. It goes to the part of the PNP what collects. I don't, hold on. Where did my Google search go? Yeah, so that is the collector. So collector of the, wait, so that goes to the, okay, hold on, where were we? We were on the junction between R8 and N5, and that was connected to the collector of Q4. Base of Q4 goes down and connects to R2 and R6. We already have R2 in here. Oh my god, this is gonna be so annoying. R1, C3. There's R2. Did we not put R6 in here? R6 is associated. No, there's R6. Sorry, R3 and R6. Oh, that's that. Okay. R3 and R6 are that whole thing, but the other end of R6 connects to N3, and then it wiggles its way. And is that R actually obscuring the trace? Yeah, it is. Okay, so the trace goes up to Q4. God damn it. So that goes up to Q4, to the base of Q4. Q4, which has an arrow going in, and then this thing coming out. Whew. Q4, arrow coming in, comes from a whole bunch of mess. Oh my god, I can't do this right now. my head is starting to shut down. N5. This is when you just have to power through and just put down what's there. This is why we organize things later on, because I'm starting to, like, I'm not really seeing patterns in this, but there are kind of patterns going on. Yeah, it's a real dang it Bobby kind of situation, huh? We even like approached the comparator yet, so I don't really know what these transistors are all doing over here. They're working. They're doing work. Okay. So Q4 was just introduced, and very badly drawn, might I add. I'm going to redraw Q4. N3, the emitter of N3, we still need to resolve. So that would be, which part? That would be the little singular tab, which is, I gotta figure out where my pointer is. The emitter of N3 is this one. This is the emitter. That goes to Q4. Whoopsie daisy. Drew it wrong. we'll just put this aside right now. We haven't even gotten back there yet. Oh, a little lower. There you go. So Q4, N3, N3 emits into this funky looking trace right here that goes up to Q4, and then it comes down to R6. But R6 can it, Did I get this backwards? Is that what's going on? Maybe R6 needs to be moved. R6 goes to N3 on the emitter side, not on the collector side. That's wrong. Shame. Shame, shame, shame. That one's going over to R9 that we haven't even touched yet. So this comes with me. Actually connects. Wait. Hold on a minute. Hold on just a minute. The tab. That goes to R. Nope, that's actually correct. And I screwed up where Q4 goes because I screwed up the emitter, collector, and base, right? Q4, the base of Q4 goes to the emitter of the NPN. The bases are in the same spot. It's just the emitters and collectors. The one without the arrow goes to the tab, and that the terminology flips between the two. Why did they do that? Why did you do that? Why would you do that? But there's a resistor in there too. It's R6 and it goes up to that junction. Okay. R6 goes up to that junction with these horribly drawn traces. And then that goes there, that goes there, and then that. Now the base of that goes to the RC. And then the collector. Okay. All right. All right. I think we got that somewhat reined in. Only a little. So now we are looking at N3, the emitter, which is the one without, wait a minute, the one without the arrow? Hold on, I fucked it up. I fucked it all up. Hold on, guys, I'm screwing everything up. I'll get this one day. Because that would be, the one without the arrow goes to the singular tab. So it would be the one without the arrow goes to the base. Damn it. Wait, no, then that's correct. Oh my god. Why is my brain like actively fighting me on this one? One without the arrow. This would be the base. The base is always this pin. So base, base, base. One without the arrow, the one with the arrow. Now on the NPN, the output is the one with the arrow. So this would be the output of the NPN. On the PNP, the one with the arrow is the input. And then this is the one with the arrow. So on the PNP Q4, or no, sorry, that's always the base. The one with the arrow is here. So that's the input to that. And that comes from R28 and a bunch of other stuff. Like way too much stuff. And then that leads us back to the op amps. This is going to end up going in the wrong direction. I'm going to have to like reverse a bunch of the components because most of my transistors have been facing the wrong way so far. So then the one with the arrow on the NPN goes this way. This goes where? We did this one. This one goes, it's not straight up, is it? Does that go all the way out to here? I don't think so. No, this one goes horizontally. So this one goes to here. No, that's not right. Does it go straight down? Where does it go? It goes towards the outside of the board. Oh, it goes right here. That's right. It just jumps over this one. So the one with the arrow, the output of the NPN, goes to R8, which goes to the base of N5. And it also goes to Q4. God damn it. Okay, hold on. It goes to the base of the N5. Yeah, okay. So this is starting to get real like RF circuity. So things are starting to kind of like get weird. And then R8 and Q4 and N5 with R8 in there. Q4, the base connected to the one without the arrow, so the output of Q4 connected to R8 and the base of N5. Okay, this is getting weird. Like that. Where else does that go? Other side of R8 goes to N3, and then it goes down to R7, where it connects to C5's ground. That might be a ground. Hold on, let's check. Go with the ohms, and I'm gonna go here to B minus. It is a ground. Okay, so this is just a pull down. So R9 goes over to something, but R7 pulls down this part of the circuit. That would be the N3, the one with the arrow going up and around to R7. Yep, I'm correct about this. R7. The ground. Now, R9, well, let's get a value on R8 and R7 quickly. R8, my 8 is 10K. Let me write that so it's legible. 10K. R7, 7.5K. 7.5 kilo ohms. So I think we got that part, because this is just ground. It should be a ground plane, but it's not. C5 and R9 I think are connected, but let me double check with the ohms. So R9 and C5, okay. So 2.4 kilo ohms. No. Am I getting 7500? Oh, 240 is 240 ohms. It's 240 ohms, not 2.4 kilo ohms, because it's 0 zeros. See a zero there, they're not just writing the value down. That means there are no zeros. So it's 240 is the actual value of the resistor. So we have, weirdly, junction here, and then we have R9. I'm going to have to like really work that in. Weird that it's there, not, well, all right, whatever. Let's pull it down a little further. R9, 240. Now, if it doesn't have a K on it, it sometimes helps to write the ohm there, just so that you know that that's actually the value. It's not like, it can't really be misinterpreted, right? Then you have a capacitor, and the value of that, C5, 100 microfarad. Put a plus here. 100 microfarad. What in the holy hell is going on in this fucking circuit? There's some weird stuff going on here, and I don't quite know how to categorize it. We'll figure it out, though. We'll figure it out, I guess. It's getting weird. It's getting really weird, chat. I don't know. We're gonna have to do something in, like, CAD program in order to wipe our brains of whatever the hell's happening here. The real ghosts were the circuits we analyzed along the way. C7 is involved with a different branch of the circuit, although it seems like we'll be getting close to that one soon. But right now, our goals are beyond your reasoning. Q4 and N5. Now, what was the one? Oh, we used it. We used it already. Okay. Q4 and N5. Now, I have these in a weird arrangement here. There's probably a better way to draw this that would give us a little bit more of an idea of how this circuit functions. We got into kind of a thing, and I started moving from the right to the left, and I think that's wrong at this point. Although we are, no, I think we're backwards on this one. So there's going to be a little bit of rearranging and figuring out sort of what the circuit structure should look like going down this cascade of bullshit that we're sort of uncovering here. But we'll stick with it for now, and we'll just see where that leads us. So Q4, non-arrow, leading into R8. We got that. That also leads to N5 on the base. That's there. That's all there. Double checked. Good. N5. The branch of N5. Now that's a weird way to draw your circuit. Hold on a minute. It's a weird way to draw your PCB, guys. What are you doing here? It's like they're trying to invoke all of the errors that could possibly happen with high-speed signals and circuit boards, because they've got these weird junctions coming off of stuff. And then, like, for instance, they're coming down here. They got a nice 45-degree angle, which is mostly just for aesthetics. Then they come down here. I just take a right angle to this pin. And that would be the output of N5. And on the input, dun, dun, dun. We've got a multifaceted jump going on here. R28 goes up. N5 is 1, 2, 3. R11, R13, R13 capacitor, R11 into the spider ground. God, I hate this. I hate everything about this. Double check, make sure that that's actually... Oh, no, it doesn't do that. It does not do that. R11 goes... That's also ground, though. Is this taking the worst route to ground that I think I've ever seen? Yes, yes, it is. It is. Look, look. This is ground. This is ground. This goes down here. It goes under this. And it goes over to here. Or it goes down to here. Somewhere in there, and probably like branching off in a weird direction, it gets to this ground. It is the weirdest thing. Also, these two grounds follow each other for a little while until they start getting nervous. One of them branches off. I think they say goodbye right here, but they're both walking in the same direction still. So it's very awkward. It goes over to, one goes over to the Zener diode, and the other one travels across the whole board and finally reaches a ground plane, where it complains that this meeting could have just been an email. But all right, so we're getting closer and closer to the comparators, which is when this will really get kind of painful. And we do have a lot of that comparator circuit vetted out already, so hopefully we can take advantage of that a little bit. But we're still kind of stuck in this bog over here, this knot of circuits that we're trying to make sense of. So far, we know there's R11 going to ground, and then we have R13 going to a capacitor going to ground. So this is a very familiar circuit structure, even though it's still bonkers, pants on head crazy. So that would be... I just forgot everything that we just determined. Where were we on this one? That was N5 and whatever R12 is doing. But N5 on the collection side, no, the emission side goes to I'll do this, that, and then I'll just do it like the other ones where I do resistor, and then it's, or no, I did it the other way around for that one, so I'll do it the other way around for this one. We'll do that, resistor, ground, and then we'll give it a little bit more space, because then I need to go resistor to capacitor to ground. And then we got to give all that stuff values. So the resistor is R11. R11. I'm starting to like read this like manga now. I can't spin it around in my head. We'll have to figure that out, like flipping the whole circuit around. There'll be a third revision of this. I don't know, maybe I'll need to work on it on my own a little bit so that I have time to actually think about stuff. 4701 is 4700, so 4.7K. The resistor going into the capacitor is R13. I just wrote an 11 for no reason, R13. I need to use this view because I can't see the numbers on the resistors otherwise. 2400, so 240 ohms again. Barely 50 ohms on that one. And then we have C7. Put a plus sign on that because my drawing of it is pretty bad. C7, which is 100 oof. So I've seen the first part of the repeating circuit structure here. That's not it. That is repeating, but that's not what I mean. That's not what I mean. This little structure here seems to be repeating. Like if, for instance, if I show you that, like this, I don't have, again, super strong movement controls, but you can see a little bit of a trend here. We got a simple RC. We've got an R and then an RRC. And then we have an R and an RRC. So something's repeating. I don't know what the hell's going on with all this stuff, though. It seems like a certain noise level maybe breaks you through the different parts of the structure, but we've got an entire operational amplifier circuit that's on top of all this. So I don't know where this is going. Maybe these cascades are just amplifying a signal to the point where we can use the comparators within their appropriate range and within the range of activating an LED. But I don't know. It all seems to come back to this trace. What else is connected to the emitter of N5? That wasn't a question for you guys. I need to look at that. N5, we've got bass, a little bit of bass, a little bit of sound. Go to R8, goes to Q4, doesn't go anywhere else. Other side of R8, of course, we've got mapped out to a whole bunch of bullshit. N5, bass. The collector is this one, which goes over to R12. So R12, that goes to Q6. Now, do we have any of that in the old drawing? We'll do a full view of this. Well, I'll just get this, move my window over, and then we go to this one. So anywhere in this drawing, do we have, what are we looking for again? Hold on, sorry. R6, Q12. We didn't mark Qs and Rs. That was kind of our mistake over here. This is what we got from the op amps. So we kind of know the other side of the op amps. We don't know much more. We don't know much else. So this structure we might want to just like reinvent for our drawing. At least this will help us a little bit though. And that's the same line as the Zener diode that connects right here. That's going to really confuse things. If I take that, which I probably don't want to, but I'm going to take it anyway, and we move it in to our other drawing, where'd it go? Oh, it didn't know I was in a different window. It would look like this. Ugh. 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 Just gonna stash this over here. I'll stash this over here because we'll keep working with this thing. We're going the wrong direction. We're going from the left to the right, and I don't know why we ended up doing that. We started with this LED, and it sort of led us on this chase. I'm gonna mercifully hit Control S too. All right, so we're somewhere over here, and we're starting to wrap this into the other circuit. And we're looking at the input to N5. We might want to look at the input to Q4, because that appears to be a little bit more pertinent. So we've got R28 on Q4, and then we've got another junction down there. We've got R17 that leads us into the op amps. That starts us off in the op amps. is a mess, guys. This whole device is crazy. And you know what? To be honest, like the circuit that this derives from probably makes a lot more sense. You can probably, because it takes a little bit to get from this stage to one where things are not overwhelming. You start to move things around and you see structures and you see repeating structures and you start to piece them together. I strongly dislike the schematics that do rail to rail. I don't think that they communicate stuff properly. I think better communication comes from signal arrows and things like that. But the problem is when you're reverse engineering something, rail to rail is the easiest way to kind of piece it together and to get it into a form that you can start to understand. All right, so the resistor that we're going to is likely R12 because we are at the input of N5, which is a junction between three things. In addition to that, somehow Q4 is involved. Well, it kind of isn't actually. Q4 is not really involved. It's just kind of here, and I don't know what I can do with it. Let's try moving it like up. Okay, let's move that over here. And I'll just connect these. But like really, I don't like to have lines that are this long like that. Because like that loop is like this weird tall thing. Like what's going on there? It's kind of confusing. I have a feeling we'll discover what this is later on down the line. But that line is also Q4 connecting to, where is that connection? That connection's down here with Z1. Z1 goes horizontally to there, and R6, and then those two down below. It also goes to C2. I don't see any other associations unless, well, depending on where this one goes. The inside one there. Bop, bop. Bop, bop. Squiggles around. And it comes up for air right below the first pin of the switch. So that's this. This would also be the Z1 junction. So that's Q4. And that would be the... Hold on. I need my reference material. I have in another window that I can just barely see around my OBS window. I have the pictures of the two transistors, so I can just look at my. It looks like I'm really smart, but I'm actually looking at a picture of them. So that junction on Q4 is the one that we're the open junction that I don't know where it goes. Q4 would be base, and then this one leading into the circuit. So that goes this way. Oh wait, no, that goes to, okay. Well, there we go. Bada bing. That looks really bad. That looks really bad. What a weird fucking circuit this thing is. I guess Q4, when there's positive on that signal, it's enough for it to switch that down to N5, which activates that branch of it, but N5 is discharged through R9 and C5. N3 is supplying from... Oh my god. Okay, so that junction on Q5... Sorry, Q4 rather. Sorry, that's this right here. So that is associated, like if we look at this trace right there, that goes down and over to here. And that leads to, yeah, that's this horizontal one here that doesn't need to exist, that connects Z1 and a bunch of other stuff. That's that part of the branch there. So Q4 is actually, we're done with Q4. N5 and all of its weirdness. N5 and its little discharging structure below it connects to, let's see, so that N5, that one is the one with the arrow. No, the one without the arrow, rather. One without the arrow goes to the side with only one pin, and that goes up to R10, which goes to power. Now, R10 going to power. Did we already get R10 on this drawing? We did not. Do we know if there's R10 on the other one? It's hard to see if we know. We don't really know. Okay, so R10 that goes to 9 volts. What is the value of R10? R10 7501 7500 7 with 500 behind it, 7.5 kiloohms. Ah, wrong camera. 7.5 kiloohms. I don't really know how to draw that here. I'm just going to do this. Stands to reason that I should have a 7.5 kiloohm on the rest of this stuff. Theme for Ghostbusters. I can't help you with that. I just can't. I cannot. No, none of this stuff really looks like it has a 7.5 kiloohm resistor on it, does it? Okay, so this is interesting. Who actually got time to relax? Somebody infected you with the flu. That kind of sucks. Yeah, I mean, this is the week to just kick back, right? The time between New Year's and Christmas. This is when the office is completely empty and you can just like drink coffee and hang out. I hope at least some of you are in that situation this holiday season, because it's a nice place to be. Okay, other side of R10 is going over to the base of Q6. So we got another PNP. We got another base sitting here. This is looking very familiar, is it not? Is it not? This is a repeating circuit structure, and this is what I would have expected to see from this circuit, since we have a bunch of LEDs that need to be triggered at different levels. But I think what's going on is we're like amplifying something? I don't know. Maybe we're just creating a whole bunch of instability. I'm not willing to like definitively say anything like that yet, though. So Q6, the collector. Wait. Oh, yeah. The collector is going to 9 volts. Not so empty, the team that works doing full training on everything. Ugh. Yeah, no, this is when all the older people would have all their vacation time. They would be able to, I want to see my family for a little while. They'd take their whole vacation now. So we know 9 volts is coming in here, and it does a bunch of stuff, and then it goes off to wherever the fuck 9 volts wants to go. R12 is on the outset of Q6. So the whatever it is, N5's emitter goes to the base of Q6 and R10, and that's it. So we've got that part of the circuit done. Excuse me, I'm like burping while I'm talking. The emitter, oh, we need to mark down, this is Q6. Marking down the designation of these things has helped us not get super confused as we're going through the circuit structure. This is just, it garners that at this point. Oh boy, here's where we start to get into the other stuff, huh? Things are gonna start to get weird. Next year I take out my vacation time. 70 days? 28 summer vacation? Oh my God. That's like a sabbatical. Man, I wish we did that here. We get like 2 minutes of vacation, and if we don't come back, they kill us. They just murder us. They straight up murk you right in the office. All right. So we got a bunch of resistors and LEDs. We're starting to get to this part of the circuit. We've done all of this, 90% of all of this, and we're now starting to bleed up into this part of the circuit. So I'm still working in the wrong direction. This is where I'd probably want to take a minute and just reverse everything, because here, check it out. I make that noise every time because it just feels like I'm losing myself. So we started over at the green LED and we worked our way this way, because I thought the green LED was an output, but it really kind of turns out, I believe that the circuit kind of more or less starts here with the coil, and there are structures here to kind of activate the coil and make it do stuff. Like, for instance, this transistor right here that's somehow associated with whatever the coil's doing, whatever the coil's up to. Q7 isn't really so much involved with the coil as it is involved with that LED. So the question is, like, what do I do? Do I make this circuit branch off from here and reverse all of this stuff so that it leads us into the operational amplifier circuit here? This is the kind of cleanup that I'm going to have to do to the drawing in order to get sort of an idea of what's going on. Because right now, if I look up schematics for, like, what would we do? Like just like a analog way to read EMF on a coil, we might find something that involves parts that look like this. Let's see if we could do a little legwork, and maybe it'll help sort of guide us into what the circuit should look like. So what I'm looking for, and it might even be a rail-to-rail circuit, but I'm looking for, like, I don't want to just look up EMF detector circuit because that's like cheating, but I guess we got to do it, right? I hate to do this because we're just gonna find, yeah, we're just gonna find this, and this is starting to look a little bit close to what we have. Not quite though. Get out of here, best circuits. Yeah, see, they're talking about ghost meter and stuff. Yeah, see, people, it's too much of a popular thing. We got a 9-volt battery, we got a rail-to-rail circuit. There is an antenna coil, but it's not connected to anything else, and it goes through a cascade of transistors that have different resistor values on them that then, I guess, eventually trigger a line that goes to everything. Yeah, so that's getting really close to what we have. It's not quite what we're doing, though. They've done some revisions on that design. I hate to just look it up. We're going to wind up finding something that's basically exactly it, right? Even that gets probably a little bit close. Well, if I find a little bit of time on Wednesday, I think I want to take like a little bit of a look at this. See, we're not using the LM3914. We're using a bunch of op amps. Okay, they've split the power supply in two. Positive and negative rails for the op amp. Basically what we're trying to do is make a very sensitive circuit. So I think I want to come back to this on Thursday. I think I'm going to spend a little bit of time Wednesday, if I can break away from people, to redraw this and kind of clean it up. This would be the really, really boring part of looking at a ghost meter. But I think we're getting closer and closer. See, the LM3916, now we've got a non-quad op amp. We've got an ASIC, but then it's also being triggered with a bunch of comparators, which is starting to look a little bit like what we were searching for. Looks like there's enough of these circuits that we can still do another interesting stream on them. I am going to finish, because we've been through a lot of this circuit before. This is getting close to what we need in order to do a second revision. So at this point, and I think at this junction right here is really the important part, we're starting to build out the rest of the circuit. I wanna spend a little bit of time with this myself just to clean it up and see what I can come up with. And then we'll come back on Thursday, and if we're working on Burn the Subs, then you'll know that I've given up on this thing and I don't care anymore. But I think there's still a lot of very interesting stuff that we can take from the circuit. I mean, basically, you guys saw the whole process of doing this kind of stuff, where it's you sort of start out with a basic premise by looking up the chips. The chips will inform you what sort of the main function of the circuit is, and then you can plan out from there and start to think about where the structures go. Then you got to drill down, get all the information on the page all at once, and you can pull structures from that, clean them up, use signal flags if you need to, split things off, and then from there, it might take a couple more revisions, but you can kind of get it into a form that makes it look like stuff that you would find online with a similar subject. And that's reverse engineering. Once you do all that, then you can look at those circuit structures and you can actually like know, okay, this is there in order to stabilize this. This is bleeding off this, that, the other thing. So we might do a part 3 on Thursday. I do need to get back to Burn the Subs. We're still waiting on circuit boards for that. And I need to order parts. I need to get those high-res connectors. I think those are direct from DigiKey. I can't find them anywhere else. 79 days, but I'm losing some days this year. They can't be saved up for more than 3 years. Hey, at least like, save it up for 3 years. It is still early. I feel like I've been working on the circuit for a year. This takes a bit out of you, huh? Well, we did a lot of good work today, so I'm going to pat myself on the back. I'll need to make a machine to do that because I don't think I can't quite. No, I got it. Okay, there we go. Cool. Yeah, I feel better. That wasn't a very long stream. We had a lot of people here, though. We'll get back on Thursday. On Thursday, we'll either work on the ghost hunting machine, or if I determine that it's too much, I can find something else, or we figure out what we're doing with Burn the Subs. But I think Burn the Subs, I'd rather wait for stuff to come in the mail for, just so we can have a coherent narrative on that one, and I don't jump to some other facet of that design. Yeah, that's all I got for you guys. Here's the end card with a bunch of stuff on it. We're ending early because I've run into circuit fatigue. This is when I'd go get a cup of coffee, use the bathroom, come back, and then keep working on it. But I'm not getting paid as much to do this right now, so I'm going to take an actual legitimate break. Ghost trapping machine, too. Yes, actually, I already did. I already did that. The ultrasonic levitation machine, the one that creates these negative spaces of ultrasonic energy, and you can float things like little droplets of water. We did that. We had a Rabaz raid during that, which is pretty cool. You're able to actually like take a syringe and just like put little drops of water and have them float in the air. But that is in pieces. I'd have to glue it back together. It's like all broken apart somewhere around here. I was going to make it a more coherent enclosure so that you could put it all together, and it would be just like a thing that I'd have sitting on the shelf. I don't have shelf space. All right. Anyway, chat, thank you. Thank you for joining me on this weird adventure. I want to get to know this device more. I'll do a little bit of revision of the schematic on my own. It'll flow a little bit better. I'll work a little bit faster without you guys here. And then when we come back, we'll either have a little bit more work to do, or I'll have an explanation of how it works if things become clear to me so quickly. It looks like this is an amalgamation of a bunch of different ones. There's the ones that use transistors, there's the ones that use op amps, and they're somehow flipping them around. Makes it a unique device. Probably does the same thing as all the other ghost detectors, which is not detect ghost. Anyway, there's all the social medias. There's the Discord. I'll be hanging out in the Discord, and I'll see you guys on Thursday. No stream on Wednesday. See you Thursday. Have a good one.